All right. Okay. And I should use this microphone, right? Yeah. Okay. All right, bonjour. Bon après-midi. Merci beaucoup pour l'invitation. J'aime beaucoup le thème de la conférence Innover ensemble parce que c'est ce qu'on fait aussi à Stanford. Et puis, bien, ça fait longtemps que j'ai fonctionné en français. J'ai fait mes études à l'École polytechnique fédérale de Lausanne, en Suisse, mais ça fait plus que 30 ans que je travaille à Stanford. Donc, je vais parler en anglais, ça serait mieux, pour les choses professionnelles. Et puis, même si vous voulez demander des questions en français, je crois que c'est vrai. Okay. So I will, explain a bit how we work together with the industry to innovate together, because I think in our field, that's really the only way to do it. After all, we are an applied field, and if what we do in academia doesn't find its way in industry, is not relevant for industry, I'm kind of saying, what's the point? So worldwide, I see really everybody now facing similar challenges, which is kind of unique because if you a decade or so ago, if you went to different parts of the world, there were different challenges. But now everybody has to achieve more and more objectives on projects, not just safety, quality, budget, schedule, but also many sustainability concerns. You find it everywhere in the world. Everybody is facing changing demographics in terms of the people we build for, but also the people that are available to manage. In every enterprise and every company I visit around the world, they say, yeah, our experienced people are retiring soon, and we don't have enough experienced people following, so we need to find very different methods for design and managing projects that allow somebody with less experience to still be successful. So these are, some of the key challenges I see around the world, whether I'm in Peru, whether I'm in Singapore, whether I'm in, Switzerland, what have you. And obviously we have to therefore find different ways of designing and building our projects. And what I would like to show to you, no, I guess I'll jump ahead a little bit too much. I would say, of course, we have to innovate incrementally in the context of the work today. But I think we also have to create the vision and the foundation for what I would call breakthrough innovations, dramatically different ways of working. Because I don't think that today's processes, adjusted a little bit, will really help us tackle the problems we face globally at scale. So that's really what we're working towards in our work. So since, I really like the projects this morning, and I look forward to the others this afternoon. In the context of things that get talked about a lot, I just want to say a few words about things that really excite me, and then things I'm a little bit skeptical about, but would be happy to adjust my skepticism if you give me good reason for that. But I really continue to be excited about parametric modeling and multidisciplinary design optimization. I think we can do a lot more of that with that. I like also, as I think it was Daniel presented, sort of AI methods that really support us humans and automate repetitive, tedious work, or give us new capabilities, allow us to do things we can't really do, see patterns in data that we couldn't see ourselves. Like digital-driven methods for managing digital and physical production, visualizations of all kinds, sort of really good visualizations that support collaboration, and the concept of circularity. Some things that I'm skeptical about is Gen AI and ML on the basis of information from past projects. I'm really not sure about that for two reasons. Few companies or organizations that I know in our field have actually reliable data from the past that is organized in any kind of reasonable way. And second, I'm not quite sure what we want to learn, because I see practices we are going to do to be quite different, much more digitally supported. So I'm not quite sure what we will actually learn from looking at data from experiences that were largely sort of in an analog way of doing work. But you can adjust my thinking if I see this wrongly. And the other one is, as I love the concept of circularity, but I'm wondering about really the feasibility of implementing circularity at a component level. I see quite a bit of work in that area, but I'm not sure. Given our need to really understand the quality of a component once it's no longer used in building like this, and then finding a marketplace that matches that with other components. Other aspects of circularity I see a bit more feasible. So just wanted to preface this. So our approach to industry or academic collaborations has really sort of three parts. First of all, create the foundation, so we have a solid foundation for innovation by making sure that industry projects are managed, run in what I would say the best currently available methods that you can just implement because they have been proven to work. We call that virtual design and construction, and I'll illustrate that. Then on that basis, to bring incremental innovations into these practices, into those projects, but also with an eye towards potential future breakthrough performance, and then prototype some breakthrough innovations. Like create a vision, like what could actually be possible, and I'll share some examples of that. Always with industry participation. So every student that works with me and many of my colleagues has to be able to function in the real world, has to be able to perform in the real world at a reasonable level, because if they cannot, then they cannot gain the trust of professionals on which they depend to get data, insights, access to real situations, which then challenge the conceptual thinking and provide really a foundation for strong conceptual thinking. Likewise, we challenge our partners in industry to think a little bit more conceptually than they often do. So I really enjoy when we challenge each other in these ways. I think you'll see that through the project examples. So in terms of creating a solid foundation, of course, we do that through our master's program. It's called Sustainable Design and Construction. Lately, it's been quite popular, which is great. But also, and I'll focus on that here, professional education. And in particular, I'll focus on actually the VDC certificate program. I should have put the arrow actually one lower. We've done a couple other, or are doing a couple other professional education programs, but the main one we've been doing is focused on virtual design and construction. So let me just share a couple examples there, and then move to research projects that happen in the context of projects managed in this particular way. So today, you would expect that any project would leverage latest technologies like BIM. You'd also expect that they use lean thinking and methods, that they use collaboration tools and approaches, and have a kind of objectives, key results, metrics way of approaching projects. I think it's pretty straightforward, obvious. The reality is that the majority of the projects that I know use some of these methods, but it's quite rare to find a project or a company that with intent from the beginning of every project carries out the project with all of those components mutually supporting each other. Because yeah, in reality, of course, you have to define the objectives of the project. You have to measure towards, manage towards them. You need to collaborate with others. You need to do so efficiently. And information is the lifeblood of any project, of any organization. You can't do anything without information. You can't do anything well without good information. And many of your projects this morning focus on that. I know these are terribly obvious statements, but I look forward to the day when I don't have to make them. So This is what prompted us to develop this concept or this method, which we call virtual design and construction, which does bring together all of those elements. It connects the definition of objectives from the client and project team perspective with how people work together, how to use technology, and the production processes that they set up and follow. And of course, they are mutually connected, right? If you need to create a particular kind of information, you need the workflows for that. Likewise, you can't carry out certain workflows without certain information. You can't have productive collaboration without accurate, up-to-date information. You can't really take advantage of the opportunity to do things concurrently if you don't design your processes that way. So that's basically these kind of interactions that we teach in this professional education program. And so these are the last few groups of professionals we have been teaching in various parts of the world. This is usually popular method in Norway, which is cool to see because they have some very cool projects there. So you see a little over 200 Norwegian professionals basically learning virtual design and construction in our professional certificate program. A third owners, a third designers, and a third builders. And you see somewhat smaller groups, but still nice groups in Switzerland and in Peru. These are lately, for some reason, the main places where people have wanted to do this program. So let me share with two examples from projects how people are using VDC. One is a few years back, but still one of the most impressive achievements I've ever seen a project team achieve anywhere in the world. And this was done, and the project team signed up for this incredible challenge because they had actually done the VDC program, and they said, hey, if we use VDC from the beginning all together, we can achieve this. Because the task was for the Pan American Games in 2019 that were held in Lima, to build all of the Olympic level facilities. In 2013, the Peruvian government said, yes, we will host the 2019 Pan American Games. In 2017, they were like, this requires Olympic level facilities. How many of those do we have in Peru? Oh, 0. How many has anybody here ever built something like that? No. So they had 16 months to design and build these Olympic level facilities for the Pan Am Games. And so this team, led by the second largest contractor in Peru, COSAPI, stepped up to the plate and said, we can do it. And people thought they were absolutely crazy because, of course, your reputation is usually on the line. You know, finishing those facilities a month later will not really help you. And so they did achieve it. And they'd achieve it by really very carefully defining the objectives that I had to pursue. I'll go here pretty quick. I probably have too many projects to show, but the idea is to give you an idea and then happy to connect on any of them, collaborate in any of them, if you like, afterwards. So they were very clear. I mean, obviously the timeline was really driving. And of course, the quality of the facilities they had to build were really the key things. So they started the project with really intense collaboration, where over, this is a picture of one of those collaborative sessions, over the first 10 weeks of the project, because you got 18 months, so you got 16 months, you got to get going. Over the first 10 weeks of the project, they had 2-hour so-called ICE session. ICE stands for Integrated Concurrent Engineering. Integrated meaning many disciplines. Concurrent, now, like together, not sending emails and looking at things and trying to get back to people. No, we solve engineering, we solve the problems now. So they had 10 of one of these 2-hour ICE sessions every day. In each of these sessions, they looked at 15 critical issues. So they really worked through all of the critical issues in the first 10 weeks of the project collaboratively. This kind of rapid cycle I've seen in other projects, having huge benefits because it reduces the number of balls in the air, right? And actually allows you to focus on what you have to actually get done and move on. Instead of lots of just in case things that we find being tackled in many projects. They modeled everything in BIM. They didn't say, well, we don't have time for that. Said, no, we can't afford, right, any mistake in construction. So we have to make sure everything we design is buildable and of course then usable and operable. So they had 60 BIMs, 60 different models, 10 main uses, 3,000 issues solved before construction. 90% of the project staff work daily with BIM. It wasn't some sideshow, it was how they did the work. And of course, they modeled the production processes, the many production processes very carefully. They also had eye sessions to develop those production processes. For example, just a small example here. The designer was Arup in the UK because they had the experience from the London Olympics. But then, of course, it had to be built in Peru. So they had lots of collaborations, had to define the common data environment, how they're going to use it. So for that, they, for example, did that also with an eye session just to illustrate, again, the connection between these VDC components. And just to highlight some of this, I mean, I'm sure you've seen this on projects as well, right? Formulation of the processes, so everybody's on the same page and follow them. And then also definition of the metrics, production metrics they're going to use along the way, like every week, to see whether how things are going or whether an intervention was needed. So this is just a very quick glimpse. The games, I think, were a huge success. Facilities worked well. And I think it's quite remarkable. You know, the project team said, yes, we can do this pretty crazy task because we will manage it with all the best tools available that we have today. More recent example is actually here from Max. He was in the previous VDC. We have just started a new program like this, but was in the cohort of professionals that graduated last year from the VDC program in Norway. He's well, I'll introduce him a little bit. The program works like this. Basically, after a week of introduction, everybody goes back to their projects and applies VDC and reports 6 times, 6 months on how that's going, and basically keeps learning them by themselves and together. And so what you will see is what he did to bring the concepts that we teach in VDC to his organization and his projects. Max is a senior, I guess I'll jump around a bit, is basically in charge of all of project management for Lidl Sweden. Lidl is a supermarket chain. I don't know if you know it, quite big one, I think mostly in Europe. And he was hired, yeah, so they build these kinds of stores. He was hired because Lidl Sweden was in this place. So each bar is the cost per construction, cost of construction of a new store in a country where Lidl operates. So you can imagine how much fun it was for the country manager of Sweden to go to headquarters in Germany with the other country managers and see this job. You're the winner of the highest cost per square meter for your stores. Of course, that's not the distinction they wanted to have. So they brought in Max. They said, we have to do something, we have to change. Clearly something is not working as well as it should in how we manage our projects. Of course, what Max heard when he joined that organization in that role was this. Well, what do you expect? Come on, each store is unique. I mean, how do you want to compare a store in downtown Stockholm with a store at the outskirts of a small town, you know, out in the country? I mean, they're totally different projects. And by the way, anyway, costs in Sweden are high. Everybody knows that. So where else should we be but on the right side of this chart? Max was like, well, yeah, that's true. Labor costs and so on is high in Sweden. But is each store really unique? I mean, this you hear a lot around the world, right? Whether a company builds schools or hospitals or bridges, you know, they're all unique. And to some extent they are. But Max was like, well, let's see if we cannot somehow simplify, you know, these stores or create more of a common basis. So over 3 years, he was able to move Sweden to this place in this chart. Reduced construction costs by 45% by bringing the VDC method to their projects consistently, not in one-off way, but across the whole organization. And basically, he did that by just systematically looking at things that were actually the same. And by that meaning, of course, some physical components, some physical parts of the project, of the stores, but also the development process, the decision-making process, just as importantly. And so basically they developed solutions that could work for every store, and the store could just say, yep, that actually works. We're done. Before, right, they would hire a designer, make the design, review it, you know, et cetera, et cetera. Takes a long time and ends up with a sometimes questionable approach. Basically, what came out of this is a master BIM, as they call it, at level 350. So quite detailed, that every manager building a new store has to start with. And then they have to build their project on the basis of this master BIM. Of course, some aspects are local and unique, so they can adjust those. But this allows them to only focus on the things that are truly unique. And they can focus on that. The rest is like, we've done it. We have learned our lessons. We know what to do. And then they have to expect it to provide updates, improvements to this master build from their store so that the next store can start with an even better starting point. Improvements in terms of the technical solutions, but also improvements in terms of just, you know, the information in the BIM, how it's being used and so on. So this has had quite a good effect. The decision latency actually currently is this was actually a few months back. Now it's actually quite a bit better, even better. But even a few months back, they made 75% of decisions within 1 week, and almost all decisions within 3 weeks. And you could say, well, that's okay. The key thing is not to change your decisions, you know. So yeah, you can make a decision fast, but then what's the point if you change later? But they only change 1 in 33 decisions. So they also make good decisions that they can stick by. Actually, the most recent data is their decision latency is 1.1 days with a variance of 1 to 5 days. So quite predictable. Before it was, let's see, I think I remember right around 5 weeks with a variance of 1 to 16 weeks. So nobody could really count on when the decision was going to happen. They're able to put the design for a store out to bid in 2 weeks instead of several months before. The design cost was reduced by 80%. The designers might not like it, but from a client perspective, not bad, as we say in Switzerland. And of course, they have to pay for the upkeep of this master BIM, but actually found that even though it provides much more value, that's actually cheaper than what they paid to maintain sort of the information they had to give to bidders anyway, before, as you can see. And they have seen, because they go out to the market with a detailed bill of materials. So a client has said, this is exactly what we want. So this is what you need to bid, general contractor. So the variance in the bid has gone down from plus minus 30% to plus minus 3%. So much more certainty. So these are, a couple examples I wanted to share from bringing VDC to projects. I think the deployment of VDC is within reach of any organization because we are not expecting an organization to do something that hasn't been proven. in terms of how to manage production, organize processes, orchestrate processes, how to collaborate, the technologies, setting of objectives, and so on. But that provides, for me, a better foundation. Why I'm interested in teaching this is I want to start innovation, improvements in the context of what I would consider good practice, not average practice. Because I think that's what I feel our role is to advance together with the industry. So I want to share a couple examples of bringing incremental innovations to projects. There's quite many. I'll give you the list in case you want to connect. And if we went to recent projects, there would be many more. But one example is around virtual reality, construction robots, and generating data-driven insights. I want to just briefly share. So this work is by Simge, a PhD student in my group, originally from Turkey. And this was actually the early days of her VR involvement. She should finish her PhD next year and has focused really on articulating the value of VR design reviews in the coordination of MEP systems for complex industrial structures. But she started by working with on the largest wastewater treatment plant in San Francisco during the pandemic, where the project team sent headsets to all the key participants. And so everybody was in their home office, but then working together in the VR to, in this case, improve the maintainability of the key mechanical room of the wastewater treatment plant. I imagine similar things like this happened around here as well. So I think this really, I think was a nice way of supporting a team with bringing in innovation to the project, because she could, master technology, understand what the project needed, and help bring the technology to the project, and then document how well that was working. Things that are difficult to do for a project team, when they're in the middle of the project. Other example is where we worked, work by Cynthia. She finished her PhD a couple of years ago, actually an architect from Uruguay, but she wanted to do construction robotics. And the first case study we were able to do with a company in Norway, Cruise Smith, was, I think, the first deployment, at least that I could find, of a robot that did actual work on site. And this was really interesting because they did, this is for drilling the holes for the installations in the concrete slab. And they did half the project with the robot and half the project traditionally. Like, was it like amazing for a researcher to see that opportunity. And so, we worked with them to understand really the differences, not only on site, but also the collaboration work, the BIM modeling work, and so on. And I was initially quite skeptical when Cynthia wanted to work on construction robotics. Said, yeah, we've tried this, normally I don't have that attitude, but there I had. And she said, well, why don't we try? I said, okay. It's tough to tell an enthusiastic student, no, you can't do that. And so I have to say, I was really surprised by the data we found on this project. I mean, for the first application of a robot, I think it was quite cool because, the schedule was a little bit better, but dramatic improvement in the ergonomics of the work, 98% reduction in the strenuous work, better quality, better accuracy, cleaner site. Cost was a bit higher, 13%, but I thought, okay, for the first application, I think it's not quite good. And so we also published with our industry collaborators, like here, paper on this, quite detailed paper exploring the difference between the traditional work and the robot-supported work. And we have now done about 40 case studies in 8 countries with about 30 different general contractors on the application of various types of robots on site. This happens through a class. We do construction robotics class. Actually, you would be welcome to participate in the class if you want to do a case study here. I would love that. We have worked with other universities in that context. It's in our spring quarter. And basically, this is a summary of what we found across all of these case studies. Safety and quality were always better in the robot-supported work. And schedule and cost, very much a mixed bag, as you can see. Sometimes also quite a lot better, sometimes quite a lot worse. Because in some cases, the robot is still quite expensive. And so if you want to have, if you want to be on schedule of similar schedule, then the cost is very high. Or if you just work with one robot, the costs are kind of okay, then the schedule is actually not better. But in other cases, we have seen also some significant improvement, as you have seen. So the third example I want to briefly share is gaining insight from all the data we can collect. It's really quite remarkable over the last few years how much data we can collect, not just in the factory, but on site in terms of production data. Actually, also for the design process with common data environments and so on. Many ways of collecting data. I want to focus here on the example left, an IoT-enabled crane hook that's on the market by a company called Versatile. Started in Israel, but now in the US and I think other parts of the world. And basically, this crane hook gives you data on every second of what a crane is doing. So you're getting quite a bit of data, typically about 20, depends on the project, of course, and number of crane lifts. But on the projects where we have been working with general contractors, it's about 2,500 data points a day. So over a few months, there's a little bit of data to look at. And so I want to show kind of some insights you get from looking at the data. This is also done in the context of another class, a class that I actually teach at the moment. We'll have final presentations in a couple of weeks. We have done a similar project. So this was a collaboration with HDCC, the largest contractor in Hawaii, building condo towers in Honolulu, typically 43-story condo towers. So this is data from 2 condo projects from last year's class, just to highlight the kind of insights you get from the data. For example, the data showed that there is a 15% learning curve with every doubling of the same types of operations. Yeah, we've always talked about learning curve, but I had never seen it really quantified. So that's super cool because this learning curve happens even if the lifts are higher and higher, right? You go up. So even though you have to transport things faster, the lifts are, the cycle time is actually less because the crew clearly learns. It was also then interesting that just after we saw the data, I happened to be on one of their sites and we ran into the most experienced person from HDCC building these concrete towers. And we asked him, said, hey, is there a learning curve? And if so, how much do you think it is? And he said, yeah, it should be about 15%. It was amazing. He hadn't seen the data. He had absolutely not seen the data. And then we said, well, here's the chart. This is all the data. And so this was kind of a confirmation for me because I believe that is with these types of methods, we can make younger professionals with less experience still successful in managing projects because they can rely on the data, but we need to make sure that the data, actually useful. So that was kind of cool. There's actually also, so they were happy to have a quantification of this learning curve. They're also a bit surprised to see that the cycle time when they do overtime on Saturdays was quite a bit higher than the normal days. It was also interesting to see the cycle time in overtime during the weekdays was actually less than the cycle time during the normal day. I guess the people wanted to go home, and on Saturday, I don't know, they figured we are there anyway. Yeah, we're not totally sure why, but anyway, it was interesting for the company to see. It was also a bit of a surprise that the cycle time was longer before and after the holidays. Yeah, after holidays, they could kind of imagine because, yeah, people get back and they have to remember. But before, they had actually expected to be maybe faster because thinking people are kind of anxious to get out of here. But the data showed no, it actually tends to be longer before and after the holidays. The data confirmed, but now they had also data that indeed during the rainy seasons, the cycle times are longer than during the non-rainy season. As you can see here, with the shaded part is the rainy season in Honolulu. It also showed that it really pays off when you do as many consecutive lifts of the same type as you can. Then you have much less idle time than when you don't. So in terms of planning the work, right? Because you don't want idle time. I mean, you have 43 stories to build, right? The crane sits idle, not a good thing. So basically, what this showed is the data allows you to quickly see, the analysis of the data allows you to quickly see where things are going just fine. And you have benchmarks to other projects that are not just anecdotes. And it allows you to see where are the outliers. And then the project team can focus on those and see what's going on here. So much more productive use of people's expertise. We continue to work with HCCC, also a bit on the research side, to build really sort of a data-driven construction management approach. And for that, they need data about everything. So here they get data from the crane, but the data they don't have is how is the work they actually do, they self-perform the concrete, how is that actually going? But they have a 4K camera on the tower crane, so we have video of the construction of the whole tower, of all the towers they've done. And so we are in the process of developing a computer vision method that recognizes, right, the like how many people are laying rebar from when to when, in what zone, how long does it really take to place the concrete, etc. So that we can then feed a digital twin of the production process with the actual data that we can then simulate and understand, understand the production better. And again, give less experienced project managers a tool that encapsulates a lot of the experience from the experienced project managers. Sort of through all of these projects, we used the digital twin framework that we came up with. Since the word digital twin came up a few times, we were asked by our industry collaborators, couldn't you come up with like a framework like 1 to 6 or 1 to 5 as we have for autonomous driving in terms of levels of digital twin? And we tried and tried and tried. We couldn't figure it out. And eventually we realized why. Because as complicated as autonomous driving is, you're talking about one actor, a driver, doing one action, driving, with one product, a car. Now, in our industry, we have many actors, architect, a rebar layer, mechanical contractor, what have you, many actors doing many kinds of actions on many kinds of components at many different scales. So like how can we come up with like level 0 to 5 or whatever it is, framework of digital twin that fits all of these? So instead, the best we come up with is this framework where we say, okay, for everything you do, you need to get data, you need to make sense of data, you need to make a decision on the basis of data, and then you need to implement the decision. Then you can get new data. And you have routine work, and you have non-routine work. So basically draw a line of where do you see the digital twin. Does the digital twin, like in this example, in this particular example, the digital twin provides support of getting data. Doesn't get all the data, but provides support. It autonomously, automatically makes sense of the data in routine situations and suggests a decision. But then the humans implement the decision. So whatever the situation, right, you can now draw with a line the performance of the digital twin you have today and where we'd like it to be, understand the cost it would take to go from one level to the next, and the business value you would get from going one level to the next. So we have quite many projects going on right now that work with industry partners to bring innovations to their projects. Quantifying the environmental impact of industrialized construction practices. If you go to the websites of all kinds of industrialized construction companies, one of the first things you typically read is it's greener. We have gone to many of them. Not a single one had data to actually show how much, or is it really? So we're working on that. I shall share these in case any of you have interest here. We'd love to collaborate, of course. We've been working with building owners and operators on strategies and policies to reduce embodied carbon in buildings. Yeah, operational carbon is big, but embodied carbon you spend now. So if you do a net present value analysis of the carbon, it's also very good to save carbon like at the beginning of a project, which is the embodied carbon. So we worked with the Stanford buildings and real estate people and developed policy and approach to reduce the embodied carbon by 20% for the time being. Formalizing client objectives. I think this relates quite closely to Brenda's project this morning. A multi-stakeholder metrics framework to assess MEP system performance. Yeah, we're excited about automating, optimizing design, but for that you need the criteria. What is optimal? And as soon as you start to think about it, you realize from whose perspective. And we haven't been able to find actually a framework that puts all of this together. A worker's perspectives on factors affecting work and productivity. If you look at the studies on productivity, almost all are done from the management level. Very rarely have workers been asked by themselves. When the workers were asked in surveys, they were typically given a list of factors that managers came up with, or asked in the content, or asked when managers are present. So we've done one first study on the turnaround industrial project in Louisiana, where we were able to talk with almost 200 workers and managers. And we'd love to actually do another case study somewhere where somebody would be interested in giving this kind of access. Another project looks at the value of building the interaction between businesses and community resilience, and how do you make a facility resilient and help the community be resilient, and vice versa. I think from a business risk management project process, quite important. Then an AR interface for simulating the use of construction robots. Yes, there are simulation environments you can use, but they rarely actually exactly the situation where the robot will be used. And we have seen in the 40 case studies, often little gotchas. And so the idea is if you have an AR interface, like a foreman can actually try using a particular robot in their space to make sure that it looks like it's really feasible. And then finally, a natural language interface with BIM. Now that's becoming a little more popular, but I think that was one of the first ones, or in that case, in that projects in that way. So now I want to share a couple sort of more breakthrough focused examples of work that really push the envelope as far as you can push it, and give a glimpse of what might be possible in the future. So first one is focused on this an automated optimal design of steel structures, which really fits in the context of collaboration and automation in the VDC framework. This was work done a few years ago by Filippo in collaboration with the project team, DPR Construction, a developer, structural engineer, steel supplier, fabricator, erector. And Filippo came to me and said, Martin, I think we can fully automate the design of course, a code-compliant structural steel for a major building. Much bigger than what we can show here. Like in the morning, we had to sign NDA, of course. So we can't really show the building, but these were buildings in downtown San Diego. So the kind of buildings you see there. And I said, what do you mean by optimal? I said, well, really cost optimal, not just optimized for material cost, like methods you can find today, but optimized for material fabrication and erection cost. So it took us a while to find a project where everybody was willing to share all of this data, at least with us. But eventually we succeeded. It took a few tries. I shall not name the companies that said no, we're not interested. So then from a research perspective, okay, we were wondering, okay, you can do it, but is there a value on a project? But also from a practical perspective, of course, they were also interested in that. So this is how we try to align the research question and interest with the commercial interest. So we used one building to develop the method, where basically Filippo worked along with the project team, was always just a step behind, but could validate that the automated model was actually producing results that were credible, past master of, and most importantly, the structural engineer. And then we were able to apply the method on a second building. And so this data from the second building, where the automated method produced the design in 1 hour versus several weeks for the typical method, and saved almost 10% in the cost of the structural steel. That is a composite structural steel with the composite with the deck, metal deck, and concrete, typical structure on the West Coast. And it's interesting to see that pretty much all the savings comes from the details. So this also shows the value of doing things concurrently. Because yeah, in today's process, you do the conceptual design first, and then later you do the details. And you might be lucky that your conceptual design aligns really well with what turns out to be producible, affordable details, or not. And here, I mean, it wasn't too bad, but still, right, through the iteration, because we do it concurrently, we can pick a conceptual design where the details also work together, and you find the optimum between, right, the main structure and the details in terms of, you know, cost. And so that was also interesting to see, because people always tell me, yeah, Martin, you know, integrating project delivery is cool, but how do I know I have the cheapest cost? Well, if your competitive bidding saves you 10%, maybe you should go ahead if you can afford the time. I mean, it's one case. It's not necessarily always 10%, but in this particular case, it's 10%. So that's an example of, right, a kind of a breakthrough, I would say, innovation, automating a major part of a design. Imagine if this was really available, the interaction between architect, developer could be very different. If you knew for every architectural scheme, you have an optimal structural design in 1 hour, you could start to think of developing projects quite differently. Of course, we need it on the mechanical energy side as well. So there's still some room for a few PhDs. Another example is building on the vast amount of production data we can now collect is really truly data-driven construction management. We were able to prototype this together with a precast company. This was on a parking structure near San Jose Airport, about, I think, 1,200 cars, something like that. And as a precast company, you live and die economically with ordering the right number of parts for tomorrow. Because the precast components are made in the yard, and then you have to tell them, tomorrow, send me these parts or these components. And if you guess right, then you have exactly 8 hours worth of work. If you guess wrong, you have wasted capacity if you don't order enough, or you have to pay overtime. This is a super good company, the most competitive precast company on the West Coast, Clark Pacific. I guess here is the cost that they incurred if they order under or over. They were on average 2 hours off each day. So this is a good company. This is what they're able to do with today's method, which basically based on using average production rates, because that's all the time you have to collect data. You don't have time for somebody to stand there all day and really pay attention. So we were curious, again, if we use the detailed data to manage to decide what to order tomorrow, because we're learning, right, on this project every day what is actually going on, could we make better decisions? And so this is the data for the whole project, 61 days of installation. In gray, you see what the project team actually ordered. So you can see on some days they were pretty good, because if they ordered exactly the right number of parts, they would be on this black line. So here on these days, they were actually quite good, but on other days they had 4 hours and more of overtime that was required. And then we basically pretended to do the project again, just on the basis of the detailed data we get from the crane hook, the thousands of data points a day. And you can see the color dots. I won't go into the difference here for sake of time, but on almost every day, we could have made a better decision. The matches more closely what then actually happened. And overall, we could have reduced with the data-driven methods the forecast error by 50%. So only plus minus 1 hour off. And we fully automated, had to, the planning process for the next day. You can't make it by hand, right? looking at thousands and thousands of data points. So giving somebody on a project 2 hours off, or 2 hours to do something else, or going home 2 hours early, whatever the case may be. So this was a kind of a glimpse in sort of, I think, something we have to really work on is this digital twin of production processes. We've seen the value of a digital twin for our product, right? BIM and its applications. And we don't have something like this for our digital and physical production processes. Not just something to look at, but something to really simulate, compute these processes. So that's a key thing we're working on, and again, love to collaborate on that. The last example I want to share is a project we are quite early on. It relates to, in a way, digital twinning of the operation maintenance of, in this case, roads, but physical access in the context of circularity. Right, the closest loop is the maintain and prolong loop. So to the extent we can maintain and prolong the life of a project, we don't have to throw it away or recycle it, take it apart, etc., which is much longer, much more. And so, of course, for roads, you can detect defects easily now. It's, you know, as in startups, you can just basically buy the technology. What is still difficult to do is to scan a road now and in 6 months, and then really match up each of the defects with the defects from 6 months. It's, at least the research we have done shows that this is very expensive to do, out of reach of project teams. So this is basically what we're working on, trying to see how can we match different scans to understand, yeah, the road was fixed, or that this is getting worse, this is getting much worse here, much faster than over here, so that we can match up the damage and the change in damage with the appropriate maintenance and fixing strategy. Because of course, you know, the sooner you fix something, the cheaper. This is data from California, ranges from $6 per square yard to $200 if you have to fully rebuild the road. So, right, but then you have, of course, also, you can't send out a maintenance crew for a little crack. So you need to figure out what is the minimum economic order quantity. And so this is what we want to enable, this kind of relationship between understanding the state of road and how it develops, and what are the best methods to maintain it, fix it. So we have a couple other examples of breakthrough innovations. One maybe, I think, a little crazy. We'll see how far it gets. Basically, idea for an architect, as soon as it starts sketching, to immediately build a semantic BIM in the background, right? Looking at millions of buildings that have been made and said, ah, this sketch could be this kind of building. And so that you can more rapidly give feedback. So Alberto is an architect, has worked an architect, and he says, this was the most frustrating thing for me as an architect. I would create a sketch. The client, V, would fall in love with that building. And then a month or two later, we would get feedback, you know, from some analyses. Yeah, this is some kind of a dream you're having, this is not going to happen. And then we had to painfully change the design, right? And so I'd love to get this feedback quickly before I fall in love with a particular design. That's sort of his motivation. We're working with a company building industrial facilities to basically create a design method that optimizes the use of industrialized construction methods in the construction of those facilities. And we want to bring sort of marrying local construction practices, industrialized construction practice in developing parts of the world. CIMA, the PhD student, is from Lagos, Nigeria, and she basically, you know, observes there, as in many other places, just an incredible lack of affordable housing. And basically also observes that the local methods, yes, they work from a cost perspective and from a comfort perspective, but are too slow. And when you show up with industrialized construction methods, yes, they're fast, but they're too expensive and to build and operate. So trying to see how we can marry the two. So in summary, as you have seen, try to show you sort of this range of building a foundation for innovation, bringing incremental innovations to projects, and then having a few examples where we, in the context of real situation, prototype what we would consider breakthrough innovations. So basically our work looks at, how ready are emerging technologies for deployment, like robotics, virtual reality, developing data-driven methods, learning from the past, learning from possible futures through many simulations. One thing I showed the digital twin framework. We have quite a few more frameworks. What's also missing, I see, is basically management frameworks. How do we manage projects company with this dramatic increase in digitalization and different skills you need? So that's another thing we're working on. And throughout the whole thing, I think you see this theme of really creating clarity between what does some kind of machine computer do versus what do people keep doing. That's also a theme that, of course, many of you, almost all of you, had this morning, which was great to see. So hopefully that has given you an idea how we help to try to contribute to innovation together with industry. We keep learning. I think industry keeps learning, so we can actually tackle the challenges we face. So to wrap up, this was focused sort of on technology, but underlying all of it is really thinking about sustainability in economic, environmental, and social terms, and in terms of top line and costs, so we can do more good and less bad. I'm a bit sad when many of my colleagues at Stanford interpret sustainability as minimizing environmental costs. Of course, we need to do that, but I think the real challenge and opportunity in sustainability is much bigger than that. And for that, we need technologies, but we also need some different frameworks to do projects. And so one of the most remarkable examples I've seen, just to sort of close here on this point, is the Aquatic Center for the Olympics in Paris. That was really a cool project for me to learn about, built by Bouygues. Because whoever decided in Paris or in France about the Olympics said, okay, we should use at least some Olympic facilities to upgrade these stressed areas. So they put the Aquatic Center into Saint-Denis, which is not, the most thriving part of Paris, and they wanted to uplift the community. And they said, okay, bidder, you have to design, build, and then operate this Aquatic Center for 30 years. And operate means you run the Olympics, you run the European Swim Championships that are on the horizon, and the rest of the time, you run the Aquatic Center as a swim center for the community. Parents can bring their kids to learn swimming, there's a water polo club, whatever, right? And so as I talked to the project executive, he says, when we looked at this, we quickly realized that the big cost for this project was the treatment of the humid air for 30 years. So we did everything to reduce the size of the swim center to the maximum possible. So we built this pool that is really expensive because it needed to be configurable into 26 different configurations by moving the floors, by moving the walls, etc. I still would love to go and see that. It was still, the concrete was under construction when I visited the project. But that allowed us, yes, we spent more money in design and construction, but that allowed us to keep the volume small and give a chance to have operating costs that are manageable given the purpose. And I was reflecting on other swim centers, right, that have fallen into disrepair. The Aquatic Cube in Beijing, I think the swim center here in Montreal, is it used from the Olympics? I don't know. In Munich, they fall in disrepair because they focused on design and construction costs. And they said it would have been much cheaper to build a bigger hall, right? Build a few pools and put a roof over it, but we would have been impossible to maintain. So in addition to technologies, I think creating sort of the right framework for projects also is really quite important. So thanks for listening to projects we're doing. Looks like you're having as much fun as we have, which is great to see. And if you can, please join us on some of the upcoming events. We have a focus on project production management on December 5th. together with the Project Production Institute. I need to find out if that's also streamed online. And then we have the Industrialized Construction Forum, 11th version of that on February 4th. That's available in person and online, that I know. So thank you for having me.
Thank you so much, Martin, and the messages that you conveyed, especially with the last slides. It was very, very nice to hear about sustainability, all aspects of it, and etc. I see already we have a question.
Thank you for the great talk. I don't know how familiar you are with the concepts of DevOps in software engineering, but I think that a lot of the overall approach that you're presenting, right, which is an evolution from agility and so on, is really get the work done, learn from it, get the best practices, and work on continuous improvement, right? I think that what you presented in the VDC and so on is reuse of best practices at the process and at the component level, right? To try to.
Yeah, it's in that sense very similar. I haven't formally studied it.
No, but that's.
Many of my students come from that world as well. But it's basically the idea. You have to break up the work.
Yeah.
So break it up, but don't forget that you also have to integrate.
You have to integrate, and no matter how good you do of a job of testing and simulation and so on upfront, which is all helping, don't try to get it perfect because you won't anyway. It's more important to get the work deployed, right?
Yes.
And learn from it, right? And construction is maybe a bit more difficult sometimes to recover from mistakes or whatever, but simulation is there for it, right?
Yeah.
And then you learn, and then the best time around, and then you have this convergence, like the case.
Yeah. And that, the legal case, I need to write it up, really shows that basically, they used to, early in the days in like 21, 22, the cycles of improvement were roughly every 2 months. When, they said, okay, we have a better master BIM now, and now the cycles are every other week. So, I mean, that's basically underscoring your point.
And,
right?
and the other point, I think, which is quite similar, we are in complex systems here, right? It's a multivariable optimization problem. And we all know that you can prove local optimization, but you can never prove global optimization. So the only thing you can do is be aware of it and monitor, right? Anyway, thank you very much.
Thanks.
Very inspiring.
No, thanks for the comment.
Dr. Fischer, thank you very much for sharing your insights. Just a brief context before I jump to my question. In both my master's and my PhD, AI has been the central theme. And I think I speak for many other students in the room, online, or maybe even your students, that as much as I find it very exciting and animating, but on the flip side, sometimes it's very overwhelming when we look at the pace at which the technology is advancing. So you mentioned the critical role of collaborations, tight collaborations with industry, but at the end of the day, so many things should work, well for you to have access to those collaborations. So I'm wondering, what would be your advice, especially for early stage researchers, when we are crafting our personal research agendas and we still are passionate about this field? So how we can navigate our, concerns that, okay, how I should be working and keep faithing that maybe I can create some meaningful contributions to the field.
Yeah, and you're absolutely right. And that's one of the reasons why I love having a community, because it's impossible for any one of us to keep up with all the developments, and exchanging that and sharing that is a way that the banking strategy I have to not end up somewhere in left field. And so in terms of the challenge you have, I ask all of my PhD students to work at 3 levels and iterate rapidly and frequently between these 3 levels, which is at, I don't know if you want to call it bottom level, but you have to give me a real situation of a person in industry that has to achieve something, do a job. Because at the end of the day, you're in a field, as I said, in an applied field. So if you're developing some kind of concept that's not useful for at least one person doing one job, I don't know, what's the point? And they struggle with that. Because I mean, that has to be extremely literal. Like on Tuesday morning, Eric, the structural engineer, is trying to do that. And that's the best he can do, but the best he can do should be able to do, it should be that. So then create a vision on that. How should the result or the efficiency, what should be better? And then reflect on that and say, okay, if it's just a matter of implementing some technology, then it's not a research problem. So then articulate in that context, what is the conceptual gap? What is missing that doesn't allow that performance? And so that's the conceptual level. And then why does that matter in the big picture anyway? Give me sort of a big picture story. So at Stanford, the students they typically start with the big picture story. Then they kind of get the concept story, and then they really struggle with the detailed story. And I have lately sort of come back to that and said, okay, no, I have to hold their feet to the fire. Because when you have a sharp, detailed story, you will get the validation criteria for your concepts right from there. And you can actually tell the story, and you can engage with industry, because you'll get feedback. Yeah, you're actually dealing with an issue we really have, or an opportunity we should have, or it's really not that important. But now that I think about it, something else is, right? So that's where we can also really make sure we find the right industry partner.
Okay, thank you so much for the presentation. I have many questions. I hope I find time that later maybe. But regarding the project from sketch to semantic 3D, looks to be a very dream project,
yeah.
Super ambitious. But
yeah.
So many levels, like many layers this project has, but starting from the training data, I was wondering how much of BIM models with details related to costs of good quality you have in hand to be able to feed this project.
Yeah, that is challenging. So that is still an issue. There is some data sets. I would have to put you in touch with Alberto where we stand on putting those together. We are actually another project which I should have all the lists. I was afraid I would forget one project. Is where we are looking at finding the buildings with the best potential for energy efficiency retrofits from publicly available data like Street View data, satellite data. And what we have learned there is the classification you can do on the basis of that data is too rough. I mean, you can classify, you can say fairly accurately whether in the European scheme of like A to G, a building is like between, in the top part or the bottom part, but it's not enough to sort of pinpoint energy efficiency strategy. And for that, we need to, at least it looks to us, we need to train sort of a model to recognize those opportunities. But for that, we would need a data set. And we haven't found a data set where you have and you need a data set with exterior and interior. And so we've developed a method which we have to improve a little bit more. And then we plan to release the data set and the method to synthetically. So we have created 100,000 buildings synthetically where the interior and exterior match, but the variation is not big enough for then a machine learning model to sort of learn a sort of rich enough context. So we need to tweak the algorithm a bit to create more synthetic building that looks to us like the most promising method to get a data set we can start to train the AI method on.
Thank you. Very interesting. We will follow the advancement of the work.
Thank you so much. I think it boils down to from my perspective, decision making. Basically projects are a series of decisions and promises and decisions. And it was interesting around the VDC framework, and the first project around Lima is saying, okay, we were able to make decisions. And I'd be curious to see around the psychology behind that. And if you were able to look into that, one issue we face is people aren't habilitated to make decisions. They don't want to make decisions, and they don't want to be held accountable to those decisions. So how is the context around the Pan Am Games made so that people were, if you make a decision, you make a mistake, it's okay. We'll fix that. Not, it's your fault and you get fired and go away.
Yeah. Yeah, that was probably should have left that one slide. Given your question, should have had left one more slide in, but I realized I was way too ambitious already. Because I have a slide that has the recommendations from the project team. And the first point is make sure the owner is on board with decision making. So it took them a little time because that was, of course, also new to the owner, but they were given the urgency of the situation, the burning platform they had. They were able to bring the owner on board and basically participate. Yeah, we're there and make decisions. And that's what I've seen. So that the little example is very much about decision making. Max says, project management organization is has to be a decision making machine. That's what he calls it. And so everything has to be set up for that. And but he's the owner. So he is driving this, and it comes as a big surprise to the designers and builders that work the first time on one of his projects. Oh, this guy really means business. Oh, and he's like sticking to the plan. And oh, he expects this information to be available. And oh, he wanted a BIM. He really meant it. I mean, they learn fast, but there's a learning curve. Yeah. So I think it's from what I've seen, it's really a question of leadership from the top management on the owner side, and then the key designers and builders. And you have to accept that mistakes we make, and then you fix them. Yeah, and then you learn, right? Exactly. And so building that trust and building that relationship, you have to actually be deliberate about. And actually, I've seen the creation of a BIM is really a good tool to build that trust, because you can see, oh, the guy actually did what we said or not. And that builds trust. But the other part, that how Max builds trust, he has a very standard way of doing meetings, but building a lot of empathy. Has parts in the meeting that, these decision meetings he has, where actually builds empathy between the group. And so the people actually, after like even a few days, open up and say, sorry, guys, I know my deliverable today is not up to speed. I had, I don't know, sick family at home or this other project. And the people understand and help. And so I'll become like a team, like a sports team. Like not everybody has, the top day on a team every day. But as a team, you can iron it out. Yeah.
Last one. Thank you so much for joining us today. It's a real honor and pleasure to having you. And my question is around IPD. It's been nearly a decade since you introduced the simple framework for IPD. After all this time, how you see this approach evolving in the industry, and despite the growing trend we see toward more collaborative approaches in the industry, why we haven't seen yet a widespread adoption for this approach?
Yeah.
Thank you.
Yeah, and I also had a slide on that in there. But I really liked your focus on capabilities, because that's also what we're focusing on. So because whether IPD happens as a contract scheme is, one thing. And that's why we changed the name of the book. The title of the book used to be called Integrated Project Delivery. That's how it started. But eventually it dawned on us, we says, no, we should call it Integrating Project Delivery, because integrated project delivery is understood as a contractual approach. And very quickly, people will come with excuses why the current project, the next project will be the one where we'll do it, which, you hear a lot. But integrating is something everybody can do. Everybody can integrate a bit more. And I should have maybe reflected on basically, if you look at all the projects, there's some aspect of integrating to advance the capabilities of integration. And yeah, to us, that seems to be the way to think about it. Of course, if you have a project where you can, it's set up as an integrated project in contractual ways, fantastic. But you can't necessarily count on that.
Thank you so much, Professor Fischer.
Thanks again. Merci beaucoup.
I just want to make an announcement, which is a very, very, very preliminary one, but we're looking with Formation Continue de l'ETS to bring the VDC program here in Montreal at the ETS. So maybe starting next September or something like that, you'll have the opportunity to learn together with Professor Fischer and to create this community of best practices level innovators. So like go to the best practices level and start innovating from then on. So. And now we continue with the next block of presentations. And my colleague Ali Motamedi will take the floor. Go ahead.
Okay, we will start the third block with no delay. We are already a bit late. Thank you so much for the presentation again. No, it was very interesting and we all benefited from an amazing presentation. So in this block, we talk about artificial intelligence, more specifically computer vision and natural language processing. Also, there would be one presentation on advanced visualizations, all in the context of digital twin, and one presentation on decision support systems. So we start this block with the presentation of Amirhossein, please. Yeah, I will share this. Yeah. Block 3. Okay, that's fine.
He's online. So,
oh, so we just okay. Oh, so the presentation is not.
Great.
Okay, Amirhossein, you can put your presentation in the presenter's mode and start.
Okay. Hello, everyone. Do you hear me now?
Yes. Go ahead, please.
Okay. Hello, everyone. Good afternoon. My name is Amirhossein Mehdipoor. I'm a PhD student under supervision of Ivanka and Dr. Al-Hussein. The title of my project is Two-Stage BIM-enabled decision supporting system for selection of suitable industrial building system in offsite construction. The challenges that we have identified for this project was the low productivity and efficiency in construction sector compared to other peer industry, and the current housing shortage problem in Canada, as well as the difficulties that the construction player right now are facing due to selecting the proper construction methodology like the offsite or onsite constructions, as well as the different type of the system. So the solution identified was the offsite construction is able to improve the efficiency and productivity. Industrial building system can be an innovative technology that offers greater automation and higher productivity, which requires to have a BIM-based decision supporting system, which we are calling here as the DSS, to improve effectiveness of decision making in the construction. The research question defined for this project is that what are the key decision-making factors in order to select offsite construction for the success of the project, and how we can develop a decision supporting system, and this decision supporting system, how can assist the decision maker to select a suitable industrial building system for a particular offsite construction project. So based on this research question, the following objectives, which are the identifying, introducing, and validating the key decision-making factors for the offsite construction project in Canada, will be taken, and we will develop a comprehensive and computerized BIM-enabled decision support system for offsite construction in order to evaluate and select a suitable industrial building system for a specific construction project in order to achieve the main goal, which is enhancing the construction efficiency by advancing offsite construction through implementing technologies by a reliable and informed decision making. The overall methodology of this project is the DSR methodology in order to address a real world problem, which is consisting of 3 steps, starting with the understanding and finding the problem, development of the solution, which is our artifact as a 2-stage BIM-enabled decision supporting system. And step 3 is the evaluation of the system by implementing a real case study to be post-validated by the expert. The first phase, which was the identification of the key decision supporting factor, was started by a systematic literature review, which we identified some initial potential factors, and these factors have been categorized and after they're validated by the industry experts in order to come up with validated factors for making informed decision making in offsite construction. These factors being assessed, validated, and ranked by the expert, and the following is resulting that the factors which is related to the time was ranked as the most important factors, and also the factor which is related to the cost was ranked as the least important factor. This slide is showing the process map for our BIM-enabled decision supporting system, which is consisting of the 2 stages. The first stage was making a decision between the offsite construction or not. So by this stage, the decision maker is going to, based on a particular project, can be assisted to have an informed decision making by accessing the user interface, using the key decision making factors, and also the KPI developed in order to make a decision between the offsite construction and conventional method, which here the conventional method means the traditional and on-site construction. So if the offsite construction deemed necessary for the project, the system is going to go for the stage 2, which is the selection of the suitable industrial building system. So the system assists a decision maker to make the comparison between the alternatives of industrial building system, which I'm going to explain later through a real case scenario. The key decision supporting factors is going to be assessed by the KPI. So this is an example of the KPI to be used in our framework. For example, for factors related to the project characteristics, like the location of the project and the project design, which for project location is the distance of the offsite facility to the project site. So the KPI defined is that if the project is more than, if the factory and the project location, the distance is more than 200 kilometers, so it is the least in favor to the offsite construction. And if the distance is less than 100 kilometers, is most in favor. This is defined for all the factors, and it continues, and it's going to be applied for in our framework. The walkthrough of the process is that for the stage 1, since it is a BIM-enabled supporting system, it's developed in a form of Revit plugin, which the user is going to access the plugin by opening the project and run the plugin, and then make the comparison between the 2 options, which is for the offsite construction and conventional method. Then the next step is to assign the rank for the importance of each key decision supporting factor for the success of the project. Based on the importance assignment by the decision maker, the next stage is going to be the automatic pairwise comparison, which the values is going to be automatically suggested by the system based on the importance that was defined by the decision maker. So there are a couple of features in this pairwise comparison based on the key area, which is this 7 area of the project characteristics: supply chain, time, cost, quality, procurement, and socio-cultural in order to make a proper decision for a success of the project. This slide shows the one example for that real case study project, that how this pairwise comparison functions. For example, here for this project, as you can see, the time is significantly more important than the cost for the project, for the success of the project. So that's why the judgment here is the system is proposing as the scale of from 1 to 9 as a scale of 9. So the system is also able to make the analysis if the pairwise comparison is consistent or not. For example, here in this case scenario, the judgment is consistent, but if the user prefers to change the judgment, he needs to make sure that the judgment is consistent. But if the judgment is not consistent, the system is going to give warning to review the rating system. And this one shows the alternative for the conventional or offset construction ranking by the performance in the pairwise comparison. For example, here in this case, the project location is more than 200 kilometers away from the factory. So therefore, in the comparison for the factor of the location, the conventional would strongly perform better than the offset construction. While for the project design, since the project design contains repetitive design aligned with the transportation, then offset construction is significantly perform better than the conventional. So this exercise required to be undertaken for all these factors which has been identified. Then by end of this process, the system is going to give a recommendation, which is in this case the second alternative, which is the offset construction, deemed more suitable for this project. The stage 2, the process is same as the stage 1, but with this difference that now the comparison is going to be between the alternatives, which are the different type of the industrial building system. In this case, the comparison is going to be made between the volumetric module as the IBS1 alternative 1, and also the prefabrication wall panel as the alternative 2. Once this alternative has been defined, the plugin is going to access the BIM model and extract the information which has been already built in to the model as a family of this IBS system in order to assist a decision maker to come up with a more reliable judgment for a pairwise comparison. For example, here is the scenario that I'm going to explain. So for this project, based on the project location, the panelized is more suitable than the volumetric because of the distance. And based on the project design, volumetric is more suitable than the panelized because the repetitive design. So the process and the methodology is same. And by the end of all the pairwise comparison for the factors, at the stage 2, for this specific project, the panelized is more suitable for this project. The last stage was the evaluation of our developed system by the expert evaluation. So we asked 15 experts to come up with the post evaluations for the systems and come up with the scale ranking for satisfaction. So which we come up with the 3.96 to be considered as satisfied. There was some area of the improvement, which was to have a more user-friendly dashboard and also simplifying the data entry methodology. As the conclusion, we did have 2 research questions, which we could partially answer the research question by identifying the factors and validating them. We managed to develop this comprehensive computerized BIM-enabled decision supporting system, which is able to evaluate and propose the most suitable IBS system for a specific project. The outcome of the research is in terms of the generalizations for the 2 aspects of the geographical region and also the different construction methodology can be generalized. And for a research limitation, it is we need to highlight that the accuracy of this result is really depends to the BIM data and how accurate and comprehensive is our BIM data. And our research is limited to the Canadian context, and some of the automation in the data extraction can be improved and expanded. For the future research, the recommendation is to integrate the AI and machine learning for the decision making. Also to track the effect of this solution as the long term. And the last one, expanding the funding for the global application. Thank you very much for listening to my presentation. I would be more than happy to answer to your question if there's any.
So you want to
These approaches are simple, that use signal persons, but they're not always reliable. So one alternative approach is using warning-based approach, which operator has a 3D view, 3D model of the environment, and also they can use sensors and cameras to operate the operation. But these techniques also comes with its own set of challenges. For example, the cognitive load that has on the operator, because the operator needs to handle the lift and also handle the view and the warning that they receive. In our previous research, we explored the use of diminished reality. These techniques use to enhance the visibility of the operators. Imagine there is an operator on the shop floor and there is a crane operator. And the operation is behind the block and the operator has a block view. So the operator can use diminished reality to see through the wall. In this research, we used the cameras that installed on the shop floor, and then we transferred the view of the cameras to the view of the HoloLens. But in this research that we are conducting, we're going to go one step further. We want to see if the operators change the position or change the head, can he be able to maintain the view? And also if any dynamic object or any operator on the background moves, is this technique will help? So for that, our goal is to design and implement a multi-view see-through vision system that enhance the visibility in occluded area and also reduce the risk associated with the blind spot and minimize cognitive load for operators. For this, our research objectives are developing this system and also implementing real-time detection and tracking of dynamic objects such as workers. So to ground our research in a real-world context, we conducted a case study. Actually, we're conducting a case study at Group Canal. So this research focused on manufacturing environment on the shop floor. One important issues that these environments may have is visibility around the heavy machinery. For example, here in we might have some visibility issue around this conveyor due to the blocking wall. So we want to see how we can use this technology to increase the visibility and then to increase the safety. To tackle these challenges, we're using two techniques. The first is diminished reality. Diminished reality is we can say as opposite of augmented reality, because in augmented reality, we try to augment virtual object on top of the real environment. But in diminished reality, we want to visually remove any real object. For example, in this picture, the house, we want to see through the house. So we use the cameras or any data to reconstruct the background. So the second approach is, the second technology that we are using is multi-view system that adapt the perspective of the viewer. We develop a system architecture to integrate these technologies. First is data acquisition. We use point cloud of the environment and also RGB depth data, and then we integrate them in Unity environment. And we did the architecture, including the data processing, including calibration and registration, and then see-through. And after all, we detect the dynamic object like workers. And then we can use any AR visualization device to see the results. Before developing our system in real environment, like the group Canam environment, we want to validate our architecture. So we develop a test setup. So for this test setup that can allow us to validate the core components of our architecture too. So we have real-time data, the live stream data coming from the RGBD cameras. And also we have, this is our test setup. So in this case, we want to see through the monitor. Imagine the monitor is a blocking environment, and we want to see through the blocking object. So the purpose is that we want to use this monitor as a portable monitor and attach it to any blocking wall or any blocking object that we want to see through it. So for our case on the shop floor, we want to use this portable monitor or install it on the wall so we can see through we can give more visibility to the operator which is working with the BIM machineries. And the second part is collecting the point cloud of the environment. So we use a 3D scanner to collect the point cloud, and we use a QR code to register the real environment with the virtual environment. For the data processing, I just briefly mentioned to the core components. We use the calibration of the cameras because we have different cameras to detect and the background to reconstruct the background. So we first need to calibrate the cameras. And then we use registration of different coordinate system. So we use transformation to register all of them and bring it to one coordinate system. So in this case, the green object is blocking view. So after seeing through, we can see any dynamic object in the environment, and also we can detect them. So I just brought some a screenshot of the result. So this is the see-through result. On top, you can see the RGBD camera, which look at the background, and we transfer all the view of the cameras and the point cloud and the real environment to the view of the monitor, and we also correct the view that ensure us that these results align with the real environment. And the second part is the object detection module. Any object moving on the background can be detected in the system. And we also have the simulation environment, which is registered to the real environment. So the data coming from the real live stream data comes to the Unity environment in a simulation environment, and we have the object detection working there. So for the see-through result, we can see, for example, we can have different view of the views, the live stream RGBD cameras, and we can see through the monitor. This setup is also working in a real environment when we want to see through the monitor. So this is in a simulation environment, and on top there, we have the real environment view. So we have this result, and we will go one step further and deploy this system in the shop floor in real environment. And thank you.
Thank you, Roghieh. It's a challenging project that has multiple modules that needs to work together at the same time. And it's also hard to explain how it works, these removing different layers from the scene. So is there any question for Roghieh or any recommendation about what other scenarios that this technology can be used? So
Thank you.
apparently it was very clear. Thank you so much. So next is the presentation of Mina on Q&A system. We received a question from Fernando in the first block regarding the project of Mahsa. He asked us why we didn't use LLMs to find information in the documents. So that's exactly what Mina is doing in parallel with the project of Mahsa with the same industry partner.
Thank you, Ali. Hello, everyone. This is Mina. I'm master student under supervision of Professor Motamedi. Before we begin, I want to thank you all for being here and for your interest today. And I'd be happy to, and a special thanks to our industry partner, CIMA Plus, which provide this opportunity for me to doing this MyText project with them. I would be happy to present my project entitled of domain-specific question answering system for infrastructure assets. So imagine that you are a project asset manager and you have this responsibility to maintain a critical bridge. And one day you are getting an urgent alert on your systems regarding to potential issue on one of the main bridge elements. For that, you have to go through all previous inspection reports to find just, for example, a piece of information. And for sure, it's not easy to do manually, go through all thousands of documents with different format types. Those are the challenges for infrastructure assets. And here we are thinking that having a question answering system would solve our challenge, but we have to consider that these information in these projects are confidential. So we have to make sure that our system is secure. So we couldn't use general question answering systems like ChatGPT. We have to implement our specific question answering. And for sure, and of course, without having a robust method or a specific evaluation system, we couldn't trust these systems. So based on these challenges, our main goal here is to build a secure question answering system for our specific use case that can handle all different format types for our existing digital twins, and meanwhile establish a benchmark for doing these evaluations. Regarding this main goal, we divided our development process into four steps. And the first one is to gather all project needs. For example, we did literature review for selecting language models, and we gather all our industry partner needs. For example, they wanted to have, instead of having a question answering system, they wanted to summarize all documents. Or we investigate available tools and APIs. So when we did our literature review, we select 2 open source language model and 2 closed source language model. So we were thinking that, okay, we don't have any benchmark in this specific field, so we have to start to establish our specific benchmark. So we create our evaluation data sets using AI and a less human resource. And after that, we implement our specific evaluation system using a Llama index and RAG assessment framework. And as you can see in the table, Llama 3 had the best performance on our specific benchmark. So as I mentioned in the challenges, all the engineers, they are facing with overwhelming task of retrieval information from thousands of documents with different format types. With different format types, I mean we have PDF, CSV file, Excel, and etc. in infrastructure projects. So we solve this problem with writing a Python writing a function with using Python libraries to handle all these documents. And this code is scheduled to run when user upload new documents into the storage, and this code will start to running and store all these documents into the vector database. If we want to go through the development process, we were using retrieval augmented generation technology, which has two different parts. The first one is information retrieval, and the second one is answer generation. So let's walk through to my system and see how this system works. First, when users start to ask a question, the system converts it into like similar fingerprint formats. And after that, system start to search through the vector database and find all relative documents related to the query that related to the question that user asked. And after that, giving these relevant documents to the language model. And here is the language model responsibility to generate the good answer and deliver it back to the user. The last stage of this step will be integrate this question answering system with our existing digital twin platform. And as you can see in the picture, this will be the final overview of our projects. So as I mentioned in the beginning, we all had this agreement that we couldn't trust these systems if we couldn't evaluate them. So now currently we are working on improving our evaluation data set that we created at the step 2. And we add different metrics or dimensions for our question and answers. For example, we have binary questions, which is yes or yes, no questions, or comparison one. Or we have the answer will be short and direct, or they need more explanations. If I wanted to give you an example here, for example, we are going to evaluate our systems like, okay, our question answering systems, the response is good on binary questions, but it's not very efficient on the comparison questions. And again, for better evaluation, we defined some metrics for quantitatively. This stage will be we define different metrics like clarity, conciseness, and relevancy. And for the qualitatively, we are using the traditional metrics like F1 score and precision recall, and etc. Unfortunately, because of confidentiality reasons, we couldn't share this. We couldn't have on live demo, but I put some examples here to show you that our that these question answering systems have the efficient response, and it's retrieved a good information from our documents. And as you can see in the last picture, you can see that it couldn't answer irrelevant questions. All questions should be relevant to the documents that these systems have in the database. Thank you for your attention, and I would be happy if you have any questions.
Thank you so much. Questions?
Thank you very much for this presentation. It's very interesting exploration and use of LLMs. I'm wondering, maybe I've missed it, maybe you've covered it and I missed it. How do you intend to deal with false negatives?
False negatives, you mean the metrics? False.
Let me explain, maybe making sure. What I mean by false negative in this case is that if you have asked a question about the presence or not of some elements in this whole documentation, and it returns the answer, no, there's nothing. So obviously there's limits to the confidence, even with all the QAs we can do, there's limits to LLMs being generative, right? It's not based on being deterministic. So false negative is a challenge. False positive could be okay. I mean, you can always ask for where does your information come from, and then you can quickly recheck and make sure this answer is good or not. But false negative, like no, there's nothing. Then if you cannot rely on the answer, how do you intend to deal with that?
Okay, our system has this feature, like it give you the source that it can retrieve the response from that sources. So we all know that ChatGPT also, they are not guaranteed that 100% you can trust me. So we can go through this for that. Maybe we can go through these resources and find if the answer and the context is in these resources. Did I
I add a note for you, because Mina is now in the process of validating system and then creating the confusion matrix and then calculating like quantitative, qualitative analysis. I think in the presentation it was flipped. So with qualitative analysis, we are dealing with experts that are checking the validation data set. So in the validation data set, we consider all the cases. For example, questions that the responses are in the document, questions that the responses are not in the document, questions that have responses in multiple documents. And then, so it's very challenging to create this validation data set, because we have to have the ground truth based on all the documentation and compare them with the generated responses. And then after, we would be able to do the analysis. So we are still at this, at the stage of developing the validation data set, and then we can report on the cases of false negatives, for example, when you're talking about it on other indexes. But having that validation data set that covers everything, we make sure that we don't get hallucinations from the Q&A systems. We just get to the right information, and we get all the information is the most challenging part, which is being done by the right.
So after you converted the initial text to a SQL query, why the two-step process? First, you use metadata to identify the document, and then you seek within those documents. So isn't there a risk there to miss some document because of bad metadata or inadequate metadata compared to the wording of the question, the initial question?
Sorry, I didn't get your questions. You mean
so there, the BigQuery part selects documents and then scan them completely, right?
Yes.
So if the metadata is not properly defined against the initial question, we may miss some relevant document and not even look at them through the verification process. So I was wondering, why do you have step 3 in the framework? Is it because of the amount of data for speed or efficiency, or is it? I'm just curious, because it seems like Gemini could probably take the whole database straight from the start and
Yes, because as I mentioned, we have thousands of documents, and giving all these contexts to the language model, it's not efficient. So here, the most important part here is that when it started to look into this BigQuery database, which is our vector database, it's not a SQL database. It's going to here it's gonna convert our text into the embed. Embed is just number, and it goes through the BigQuery database and find the most similar documents to that query.
Based on metadata, right?
Yes, based on
So
the
this is
metadata.
where I see a gap between the initial question and the answer that could be in number 4, but is not selected in number 3 because metadata has limited upsides in terms of identification of the proper document.
Sorry,
The documents, all the documents are already in space.
and we are chunking. Before we wanted to go through find the relevant documents. Here in the pre-processing data, we are chunking all the text as for example, paragraph by paragraph, and get it to the BigQuery data, BigQuery. Yes, exactly.
So everything is there, and then in step 3 per question, we. Any other question? So thank you so much.
Thank you.
Last presentation is presentation of Benjamin on a computer vision project related to waste management in construction.
Hello, everyone. Thank you for joining in today. My name is Benjamin. I'm a master's student here at ETS under supervision of Dr. Motamedi, and I'd like to present my project, Data Augmentation for Automated Construction Waste Sorting using Conditional GANs. That's a large title, but I dig through it. And just want to give you the info that this project is supported by the MyTax Accelerated program in collaboration with Waste Robotics, a company specializing in AI-driven robotic solutions for waste sorting facilities. And a disclaimer note, I cannot share deep details due to the confidentiality reasons. So let's jump through it. So construction waste accounts for nearly 40% of the global waste. And although it contains valuable resources and materials, it's mostly being end up in landfills. And the portion of it that it's being recycled and reused is currently being transported to the waste sorting facilities and being manually sorted. So by this manual waste sorting, we mean that at the end of these process, next to the conveyor belts stand the human laborers that manually identify these items and pick them based on their identity and drop them into the dedicated bins. This has multiple downsides. To start with, the health of these human workers are at risk because of being composed to the contaminated and potentially hazardous materials that are there because we're dealing with waste. And of course, they have limited capacity in order of picking up the items and dropping them into the designated bins. That is why companies like Waste Robotics exist here to provide robotic substitute to these old school versions. And with their solutions, they improve the scalability of this projects because they're no longer limited to the work hours of humans. And they are more efficient because the robots do not get tired. And of course, they can save a lot of money for them, for the waste sorting facilities. But if we want to take a closer look of how these systems work, we need to know that these robots, in order to pick the correct item and dispose it into the correct bin, we need to have visual data. We need to know what item is where on the conveyor belt, that we could coordinate with the robot and tell them to pick it up at the right time. So we do have a, this is an example. This is not a based robotics vision system, but some sort of example I found in the literature that in these vision systems, normally there is a camera facing down to the conveyor that as the products, the waste items are passing by on the conveyor, it will scan them, and based on their type and position, they will be they will coordinate with the robots. So the next step, and as they go through, the robot will pick them up. So to more give you detail on my research scope in this project is that, so we found that for these robots to sort the waste, at its heart, we need to have a vision system, and that vision system is actually an AI object detection model. So for this AI object detection model to work, we need a huge amount of training data. These training data should be labeled and annotated image data. Currently, these image data is coming from the limited library of scanned items in waste robotics library, and from data from previous projects that they have finished. That is where I step in. I mean, my project steps in to create and try to augment these images using a generative model. I know Professor Fischer mentioned that he's skeptical of using generative AI, but in this specific domain, I guess it's not bad to use it. So this generative AI, this GAN model, will be used to generate somewhat similar items and diversify the current items that they have in their library, to then try to increase the accuracy of that AI object detection model, which ends up to increase the overall accuracy of sorting the correct items. So I want to give you an example of how this GANs work. These are trained on the data set that, the limited data set that Waste Robotic had. And as you could see, this is the iterations that will give you, for example, for the class rubble that we have on the left side of the image, they are generated from pure noise. And on the right side, we have another class of waste items, which is bottle. Currently, we have limited training data, and we're just testing it out. But later, this could be more developed on the other classes of waste items from construction and demolition. And how this generated data will be used is basically, the goal was to remember, the goal was to increase the accuracy of the object detection model, which was used. So what we do with these data, so we have a bunch of real images of different waste class items. By the way, normally a conveyor belt from top view looks like this. So a bunch of waste items are there, and some of them are important for us that we want to pick. That's why we need to train our model on those specific data. So we do have some real images. We combine them with our generated images and place them on the images that we have of empty conveyor belts. And as we did manually with our algorithm, place these items on the conveyor, we know exactly where are they placed. So we do have the annotations, and we'll end up with images like this that we could use in the training process of the object detection model. I would like to thank you, and I'm happy to answer any questions.
Thank you, Benjamin. Any question? So the idea is that how we can have an object detection model for construction waste without having a very large data set of images, and how we can these generative models for that. If there is no question, thank you so much. So that was the last presentation for this block. We will have a short pause of 10 minutes, and then we'll come back for the last block of the presentations. Thank you.
Allô, allô? Tout le monde. Everybody come back, please. Si vous voulez qu'on finisse et qu'on ait notre cocktail, il faut bien commencer le dernier bloc, n'est-ce pas? Alors, comme début pour notre dernier bloc, on a une autre présentation d'un de nos partenaires les plus fidèles, CIMA+, et ça va être une présentation de la part de Julien Jean-Charland. Je te donne la parole.
Merci, Ivanka. Donc, bonjour à tous. Just for the sake of it and balancing everything, I'll do the presentation in French. So, but if you want to ask questions afterwards, no worries, doing it in English. Donc, CIMA+, je fais une petite présentation. On n'est peut-être pas connu tant que ça de l'extérieur de l'industrie, mais on est quand même la troisième plus grande firme au Québec. 3200 employés à travers le Canada et plus maintenant. Donc, on couvre vraiment d'un bout à l'autre le Canada. On est une propriété là, à 100% de ses employés, donc associés, employés, tout ça sont partenaires, actionnaires là, dans l'entreprise. Pour nous, c'est quelque chose qui est super important, l'entrepreneuriat puis la participation des employés dans le développement de la firme. Marché, donc nos quatre grands marchés porteurs, infrastructure, bâtiment, transport, énergie, ressources. On nous voit un peu partout là, dans différents projets. Ce matin, je vais emprunter un de nos projets ce soir pour rentrer à l'hôtel avec le REM. Donc, on fait vraiment là, des projets d'agrandissement d'écoles jusqu'à des projets là, plusieurs milliards. Donc, ce que je voulais parler un peu aujourd'hui, c'est un peu le contexte économique au Québec, puis l'impact que ça a sur les firmes, que ce soit ingénierie ou même mon collègue Sébastien tantôt, les firmes d'architecture. Donc, le Québec comme tel, on est reconnu comme étant une culture très dynamique, qui a beaucoup, pas grand-chose à envier ailleurs dans le monde. On est très choyé dans comment on vit ici. Une des forces qu'on a économiquement, c'est notre réseau, notre écosystème ici. Donc, on le voit très bien avec les réseaux d'universités, donc comme on l'a actuellement. On a aussi des centres de recherche de pointe dans différentes industries, puis une culture entrepreneuriale là, qui est très dynamique. On a aussi des secteurs porteurs, donc on parlait de l'intelligence artificielle quand même beaucoup aujourd'hui. Montréal est une des plaques tournantes, l'intelligence artificielle à travers le monde. Au niveau des technologies propres aussi, on est un endroit où est-ce qu'on excelle puis on attire beaucoup d'investissements par rapport à ça. Le gouvernement, bien sûr, nous aide par ses politiques pour soutenir l'innovation, soutenir la stimulation de la croissance économique. Puis vraiment, après ça, la culture d'entrepreneuriat, comme je disais, c'est quelque chose qui est très enraciné au Québec. Par contre, il y a quand même certains enjeux sociaux. Donc, l'innovation, s'assurer que c'est accessible à tous. On s'entend, comme dans la plupart des industries de pointe, celui qui paye le plus cher va avoir accès aux dernières technologies. Mais ce qu'on veut quand même, c'est être capable de démocratiser ça là, pour l'ensemble des gens. Transition écologique. On doit encourager des innovations vertes ici. Je pense que plusieurs d'entre vous le savent, nos bâtiments sont performants pour le climat qu'on a, mais ce n'est pas des bâtiments exemplaires. Le fait qu'on paie notre électricité là, à très faible taux fait en sorte qu'on n'innove pas nécessairement dans ces domaines-là, alors qu'on aurait avantage à y gagner, à investir beaucoup plus là-dedans. On le voit aussi là, avec la transformation du marché du travail, l'automatisation, de la numérisation des emplois. Plusieurs d'entre vous ont parlé d'automatiser certaines décisions, certains designs, la modélisation. Donc, on voit tranquillement le marché du travail complètement changer à ce niveau-là. Donc, dans les enjeux que nous autres, on vit du côté des firmes de génie conseil, mais aussi au travers de l'industrie, il y a certains retards technologiques là, et numériques qui se fait sentir. Ces enjeux-là sont principalement dus à différents facteurs. Je vais passer certains d'entre eux. J'en parlais un peu tout à l'heure, le coût d'entrée aux technologies de pointe est quand même de quoi de très important. Certaines technologies comme l'intelligence artificielle, de plus en plus, sa barrière d'entrée-là tend à diminuer, mais ça reste que des entreprises comme des PME n'ont pas nécessairement la capacité d'entrer dans ce type d'avoir accès à ce type d'innovation-là ou à ce type de technologie-là. Donc, ça fait en sorte que l'industrie comme telle ne peut pas évoluer aussi vite qu'on souhaiterait. Compétences et formations, compétences numériques, l'ETS en est un exemple de se réinventer, intégrer les nouvelles technologies, aller encore plus loin avec l'éducation des jeunes ingénieurs. Ce qu'on voit par contre ailleurs, c'est qu'il y a beaucoup de programmes ou beaucoup d'universités qui stagnent à ce niveau-là ou qui sont en retard. Donc, ça fait en sorte que la main-d'œuvre qualifiée au Québec là, devient de plus en plus difficile à aller chercher. Il y a aussi un aspect, une culture de formation continue qui, dans les firmes d'ingénierie, n'est pas là. Je remonte à quand moi, je suis rentré dans le domaine, des gens qui n'avaient pas eu de formation sur AutoCAD en 10 ans, c'était régulier. Aujourd'hui, à la vitesse que vont les outils, les logiciels, on ne peut plus se permettre ça. Donc, cette culture de formation continue-là devient extrêmement importante. Même chose au niveau innovation, recherche et développement. Vous allez voir plusieurs firmes, que ce soit d'architecture, d'ingénierie, n'ont pas de cette culture-là, cette fibre-là, n'ont pas de ressources dédiées. Tout est fait un peu sur le coin d'une table où parle les soirs, les fins de semaine de quelqu'un qui est passionné. Ce qu'on voit, c'est que cette culture-là est beaucoup plus implantée ailleurs dans le monde. On est partenaires américains qui, eux, ont des départements de 50, 60 personnes qui ne font que ça, de la recherche et développement. On est complètement ailleurs. Il y a un ingénieur en structure à Vancouver avec qui on travaille. Ils ont un laboratoire pour faire des tests. Au Québec, on ne peut même pas imaginer avoir ça. Donc, ce n'est pas dans la culture de l'entreprise. On veut vraiment que ce type de réflexion-là, là, maintenant, soit plus présent. Donc, il y a des choses à travailler là-dedans là, au Québec. Bien sûr, la concurrence internationale, on ne se le cache pas. Au Québec, on est quand même choyé avec la langue française, mais avec les dernières innovations au niveau de l'intelligence artificielle, traduction instantanée et tout, on se retrouve de plus en plus là, à être exposé à des menaces externes donc, qui n'ont pas nécessairement de limites ou de barrières là, par rapport à la langue. Donc, qu'est-ce qu'on fait avec ça? Un peu, là, nous autres, dans notre rôle, expliquer un peu, on est là pour donner une expertise. On est là pour aider dans la réalisation d'un projet. On est un service spécialisé. Donc, on est un partenaire pour un client dans un projet. On n'est pas là pour nécessairement vendre quelque chose ou quoi que ce soit. On est vraiment là pour arriver avec une plus-value. On l'a vu tantôt avec le professeur Fischer. Donc, on est capable maintenant d'avoir des algorithmes qui développent des solutions standardisées beaucoup plus facilement. Donc, on parlait de quelques minutes pour un projet, une structure de bâtiment, alors que nous, de notre côté, aujourd'hui, traditionnellement, ça peut prendre plusieurs jours arriver au même résultat. Donc, comment on est capable aujourd'hui d'amener cette technologie-là, d'amener notre expertise, puis d'en faire bénéficier un client, c'est ça exactement notre rôle. Donc, chez nous, comment on le vit? Oups, pardon. Celle-là. Donc, avoir une vision claire de destination. Chez nous, c'est là qu'on travaille très fort. Notre nouveau président, son slogan, c'est Destination 2027. Donc, lui, quand il a pris la présidence, a fait un plan sur les 5 prochaines années avec des métriques, une cible, des objectifs très, très, très chiffrés. Donc, on parle de plus de 50% en termes de gens, plus de 70% de revenus, doubler nos profits, tripler notre présence à l'extérieur du Québec. Donc, il y a plein de choses par rapport à ça qui viennent appuyer après ça différentes stratégies. On parlait de l'ADN de l'entreprise tout à l'heure, l'entrepreneuriat, donc extrêmement importante pour nous. Donc, ces valeurs-là viennent après ça nourrir notre innovation, nourrir où est-ce qu'on investit notre argent. Puis après ça, ben, il y a vision de l'avenir. Donc, les partenaires externes comme l'ETS, partenaires externes comme on a d'autres chaires de recherche dans lesquelles on participe, soit à l'Université Laval, à UBC, à une autre université en Ontario à qui on participe sur différents sujets, mais nous amènent ces informations-là, nous amènent cette vision de l'avenir-là, nous amènent où est-ce qu'on va être dans 5, dans 10 ans. On fait la même chose aussi avec des partenaires privés, de se concerter un peu là, où est-ce qu'on s'en va, où est-ce que l'industrie s'en va. Donc, à partir de ces éléments-là, on vient créer différentes choses. Actuellement, on en parle beaucoup de la donnée aujourd'hui en termes d'intelligence d'affaires. Donc, tout ce qui est standardisation, centralisation de la donnée. Professeur Fischer, de tantôt, je me voyais beaucoup dans ce que vous apportiez en termes de faire des choses par les projets passés. Donc, d'aller chercher cette donnée-là. À certains niveaux, je suis entièrement d'accord qu'elle n'est aucunement utilisable. Par contre, il y a des choses pratiques qui sont encore valides même aujourd'hui. Le raccordement d'une toilette sera toujours le raccordement d'une toilette. Donc, c'est d'aller chercher cette donnée-là, de la convertir, de l'intégrer dans nos pratiques aujourd'hui. Personne, en tout cas, pas chez nous, en tout cas, on n'a pas vu la vitesse à laquelle l'intelligence artificielle allait devenir aussi importante dans nos vies. Donc, cette transformation-là, cette prise de conscience-là au niveau de la donnée s'est faite là, très rapidement et on voit cette nécessité-là là, aujourd'hui là-dedans. On a regroupé aussi beaucoup nos groupes, toutes sortes d'experts qu'on a à l'intérieur de l'entreprise et à l'extérieur. On parle d'intelligence artificielle, on a une équipe maintenant. En 1 an, on est parti de 0 ressources à 6 ressources dédiées à temps plein en intelligence artificielle. On a monté un groupe avant qui était des experts qui étaient répartis dans différentes portions de la firme. On a monté un groupe uniquement axé sur la livraison numérique, où est-ce qu'on se concentre vraiment sur tout ce qui est collaboration, tout ce qui est donné dans un projet. Puis on aide nos groupes de travail un peu partout là, à stepper up en termes de maturité à ce niveau-là. Puis au niveau des technologies, aujourd'hui, ce qu'on essaie de faire, c'est d'extraire la donnée, extraire l'expertise que les gens ont pour aller chercher. On parlait de la nouvelle génération qui vient, comment on est capable de les éduquer, de les rendre autonomes plus rapidement. Bien, c'est là que ces nouvelles technologies-là vont nous aider, d'être capable d'extraire cette information-là, d'extraire la matière grise des gens et d'être capable de la retransmettre là, à une nouvelle génération après. Pour nous, c'est vraiment là qu'on s'en va, ou est-ce qu'on veut être capable de tout documenter, tout répertorier, puis après ça, être capable de le transmettre aux prochaines générations. Donc, pour nous, les nouvelles innovations de rupture, comme l'intelligence artificielle, c'est vraiment une opportunité de se repositionner comme industrie, de se repositionner comme entreprise, que ce soit dans des nouveaux services auxquels on réfléchit, que ce soit dans des nouveaux marchés. On est vraiment là pour être en état proactif, comme c'est écrit ici, en état proactif par rapport à ces technologies-là. On peut vraiment façonner où est-ce qu'on s'en va, plutôt que de subir comment l'industrie va évoluer. Merci à tous.
Questions? Avez-vous des questions? Oui, Charlotte.
Merci. Moi, j'ai une question, mais plus d'ordre de la curiosité. Je suis désolée, je reviens à chaque fois avec ça, avec le développement durable et l'économie circulaire, c'est un peu mes topics. Donc, effectivement, je suis plus enclin à poser ce type de questions. Mais du coup, moi, je voulais avoir un peu votre avis par rapport à ça. Comment vous voyez les choses par rapport aux innovations et le lien avec les projets? Ce que je vois, du coup, je suis sur votre site internet, donc je regarde un peu les scopes que vous avez qui sont effectivement changement climatique et projets durables. C'est quoi un peu votre perspective et votre vision par rapport à ça?
Bien, ce qu'on essaie, c'est de donner le plus d'outils possible aux concepteurs. Donc, dans notre cas, une des choses qu'on veut lancer avant la fin de l'année, c'est l'ensemble de nos projets de structures de bâtiments vont pouvoir sortir en temps réel exactement le nombre, la tonne de CO2 équivalente du design. Puis, on est en train de bâtir justement cette intelligence-là pour être capable de benchmarker nos projets, puis de venir, je dirais, depuis quelques années, c'est la mode dans l'industrie de l'ingénierie. On dit, OK, combien de pourcentage d'honoraires sont liés à des projets verts? Mais qu'est-ce que tu définis comme étant un projet vert? Ben, nous autres, on a bâti tous nos KPI de qu'est-ce qu'on voudrait avoir, qu'est-ce qu'on définit par un projet vert. Puis là, on est en train justement d'automatiser cette génération-là pour se bâtir une base de données, puis qu'on soit capable de dire, demain matin, je fais une école à Saint-Jérôme. C'est quoi que je définis comme étant une école verte? C'est quoi que je définis comme étant une école qui dépasse, on va dire, le standard ou même les très bonnes pratiques, là. Oui. Puis c'est gardé historiquement pour être capable de revenir dans 3 ans. Puis tu en fais une à Saint-Eustache. Puis là, tu es capable de comparer pour différentes raisons. Tu sais, ça peut être, tu vas arriver en termes de structure, tu vas arriver à une structure qui va être un petit peu plus robuste pour différentes raisons, parce que celle-là, l'école est un endroit de sécurité publique. Fait que le besoin de résister à différentes charges supplémentaires et tout. Fait que tu vas être capable d'indiquer pourquoi tu dépasses ton target de verre. Puis nous autres aussi, une des choses qu'on veut faire, c'est d'être capable de descendre ces targets-là pour être capable d'imposer certaines innovations à nos concepteurs.
Oui, merci pour la présentation. Tu as mentionné très souvent l'intelligence artificielle. Il n'y a pas un danger de penser que l'intelligence artificielle est le silver bullet et la solution miracle, d'une part.
Oui.
Garbage in, garbage out. Donc, ça, c'est une chose. Et si on met dans la même phrase intelligence artificielle et développement durable, surtout si on parle d'utiliser l'intelligence artificielle à toutes les sauces, il n'y a pas un paradoxe, c'est-à-dire que la meilleure solution en ingénierie est toujours la solution la plus simple qui résout le problème. Je pense que l'intelligence artificielle est un peu un mammouth qu'on peut utiliser à plein de choses. On connaît toutes les dérives. Donc, enfin, juste en commentaire, je voudrais entendre ton opinion là-dessus.
Définitivement, c'est comme utiliser quasiment une bombe atomique pour essayer de tuer une fourmi, des fois, là. Il y a beaucoup de gens qui ont comme c'est à la mode ces temps-ci, il y a beaucoup de gens qui ont le réflexe de dire OK, parfait, on va faire un projet d'IA là-dessus. Mais la réflexion que moi j'ai souvent avec eux avant d'embarquer là-dedans, c'est de dire OK, est-ce qu'il y a une formule en arrière de ça? La réponse souvent est oui. Parfait, on va juste faire une routine, on va la programmer. Pas besoin d'intelligence artificielle, tu vas avoir input, output. Donc, mais c'est entièrement à la mode. Les gens, c'est le réflexe. Mais oui, on a créé un écosystème à l'interne de 3 équipes. Donc, on a mon équipe qui est livraison numérique, qui s'occupe vraiment des données de projet. On a une équipe spécialisée en télécommunications, création de systèmes pour des clients, développement logiciel. Puis, on a une équipe interne, après ça, une équipe TI dans laquelle est inclue une équipe d'intelligence artificielle. Puis, à chaque fois qu'il y a un projet, une demande qui rentre, mais les 3 équipes, on s'assoit ensemble, puis on regarde, OK, c'est quoi le vrai besoin? Parce que souvent, c'est pas juste le besoin qui rentre, c'est quoi le vrai besoin derrière? Puis quelle est la meilleure solution pour le faire? Fait que il y a pas, c'est pas, on pèle tout dans le cours de l'intelligence artificielle, non, effectivement.
Bon. Merci beaucoup, merci Julien. C'est super d'entendre tout ce que nos partenaires font et d'apprendre d'eux aussi. Alors, merci. Yakine? Yakine, can you share your screen, please? Donc, on a une autre présentation qui va être en ligne parce que c'est un étudiant qui est en train de finir sa maîtrise. Son projet est assez futuriste, comme vous pouvez voir aussi de son fond d'écran. Donc, Yakine, on voit ton écran maintenant, si tu m'entends. OK, parfait. Donc, on te donne la parole.
OK, vous m'entendez?
Oui, on t'entend assez bien aussi.
OK. Hi, everyone. My name is Yakine Zerrad, and I am a master's student. And today I will be presenting research conducted with Ivanka Yordanova on designing for the extreme computational strategies for adaptable and sustainable housing in northern Canada's permafrost region. And this work addresses the architectural challenges in northern Canada, focusing on combining modern computational tools with innovative construction methods like cross-laminated timber, CLT, and 3D printing. And to start, the housing crisis in northern Canada, particularly in regions like Inuit, Nunangat, and Nunavut, is a complex issue. And it's not just about lack of homes, but it's also about the historical injustice, social challenges, and environmental factors. And many communities face extreme overcrowding with deteriorating homes that struggle to withstand the permafrost environment. And in some cases, overcrowding rates reach as high as 72%, leading to what we call hiding homelessness, when we can find different families sharing the same space or the same house. And traditional construction techniques often fail under these conditions, leading to rapid deterioration and negative health and socioeconomic consequences. So here we have an example of a house in Kugaruk. As you can see, a bed and worn out walls, along with exposed elements of the house's structure, highlighting the poor quality of housing in northern Canada's harsh condition. And before going to the research objectives, I would like to give you some definitions used in this research. The first one, cross-laminated timber, which is a prefabricated wood panel made from layers oriented perpendicularly. The second one, which is 3D concrete printing and additive manufacturing methods that construct building elements by layering materials. And we can have some example like concrete and geopolymer to reduce waste and enhance flexibility. The third one, which is computational design, the use of algorithms and simulations to optimize architectural designs and analyze performance. And the last one, permafrost, a ground that remains frozen for 2 or more years. And we need to, it requires special attentions for example, for the foundation, the type of pipelines, and also the essential services. So here we have like the two research questions. The first one, what role can computational design play in optimizing these materials and construction techniques for extreme weather conditions? And the second one, how can housing design integrate indigenous culture values and traditions while simultaneously solving the technical and the logistical challenges forced by permafrost region? And the main objective of this research is to develop a computational design methodology to create adaptable and sustainable housing in northern Canada's permafrost regions by using tools like Amoeba and Canva 3D that we can find them in Grasshopper, Rhinoceros 3D. And the objective is to optimize the structural configurations and material usage. And we integrate also the cross-laminated timber and CLT, cross-laminated timber, CLT, and 3D printing to address the challenges of remote construction. And of course, to meet our research goal, it is important to make sure that the housing design respect and incorporate indigenous architectural traditions. And to address the challenges posed by extreme environments, we explored 6 projects located in different climate zones, each demonstrating adaptive strategies and technological advancement. For example, the Halle 6 research station is designed for mobility and resilience in polar climates, while the desert nomad house demonstrates innovative solutions for a arid environment. And we also have an example in Canada, which is the CHARS project in Nunavut, provides a direct example of how advanced technologies can be applied to harsh Arctic conditions. And by analyzing these projects, we identified common strategies and innovations that inform the computational design methods used in this research. So to systematically analyze the selected projects, we categorized them into broad themes like energy efficiency, sustainability, and adaptability. And we also make some subcategories to dive deeper, addressing specific aspects such as renewable energy, water management, and thermal insulation. And this framework allowed us to understanding the nuanced requirements of each climate zone and optimize designs accordingly. And this categorization was crucial for identifying opportunities for technological advancement and policy recommendations, aligning the analysis with the objective of this study. So here we present a detailed performance matrix comparing the selected projects based on key criteria such as location, resilience, and technological integration. And we can take, for example, projects like International Space Station and NEMO that demonstrate exceptional use of advanced construction systems, while CHARS excels in adaptability and thermal insulation. And this matrix highlights the distinct and gaps across projects, providing insights for development solutions for the permafrost regions. And the findings from this matrix directly inform the design proposal, ensuring that these strategies adopted are both practical and innovative. And from this comparative analysis, it's clear that each project excels in specific areas, and these results guided the development of our design proposal, where we integrate the most relevant strategies for Arctic housing. And the research contributes to a new theoretical approach by combining prefabricated elements like exterior walls, interior walls, modern kitchen and bathroom. And in our case, we have the CLT and on-site construction, which refers to assembly and 3D printing at the site. And this hybrid method reduces transportation cost by minimizing heavy materials and speed up construction in extreme environments. And by respecting the environment, by using local materials with 3D printing, we can reduce environmental impact and carbon footprint. And finally, as I mentioned before, this approach ensures that the housing design aligns with the local needs and respect indigenous traditions. And here we have like three examples of Inuit architectural heritage. The first one, which is topic, and it is more seasonal needs, and made of animal skins and wooden frames. The second one, igloo, and made with a snow block domes. And the last one, cool winter house. And this one is more permanent for Inuit architecture. And it is a semi-subterranean structure built with a combination of stones, sod, and bones. And these three examples shows the ingenuity of using local materials and at times transforming them into essential element of the house. And now moving to our methodology, our workflow starts by identifying the main part of our construction system. Here we have the efficiency analysis, CLT, foundation, the foundation, and the 3D printing. Next, we use tools like Ladybug and Honeybee for environmental analysis, while Amoeba 3D and Caramba 3D help us to optimize the design. And finally, we combine 3D printing and CLT to create a final design that is eco-friendly and built for the extreme environment. And using the Grasshopper Rhinoceros 3D interface, parametric design becomes a key part of this of our workflow. We created a flexible parametric model that integrates CLT and 3D printing technologies, enabling us to quickly explore different configurations and help us to choose the best design option. And in this slide, we can see that the slide shows the results, highlighting the optimized components like the building envelope, the subframe, the structure, the materials, and the energy efficiency. And the Caramba 3D was used to analyze the stress, load bearing, and displacement analysis, while Ladybug and Honeybee was used for energy performance and solar efficiency optimization. Now moving to the transportation logistics. The slide shows the transportation logistic for the construction. We first transport the building envelope, the core services like plumbing, electrical systems, the raw materials, and to 3D printing to the site. Once everything is on site, the construction process begins by using these components to build the final structure efficiently. And here we can see the detailed construction process. It begins with preparing the foundation, which is critical in permafrost stations to ensure stability. Next, we install the steel subframe for the 3D printing. And the main structure components are then printed on site following by the quick assembly of the prefabricated CLT panels. And this method not only reduces the time needed for the on-site labor, but also ensures that the workers spend less time in the harsh weather conditions. And here we can see the program and design of two-story model unit. The first floor, which is more public space, where we can have the living space and open plan living space, the bathroom, the living space, the office, and the storage, and of course the kitchen and the stairs. The second floor, which is more private spaces, where we have 2 bedrooms with a bathroom and open to below design and the skylight for natural lights. And now that we have covered the design, we can move now to the discussion of the project's current limitation and potential area for future work. One of the main limitation of this study is that it remains theoretical, and there is no, it has not been yet applied in a real world condition, and there's a lack of empirical data on the long-term performance of the proposed design in Arctic climates, durability, and for the life cycle materials, and for the material characteristics and their ability to withstand the extreme environments, such as the heavy snow loads and permafrost, still required real-world validation. And to wrap things up, this research presents a novel approach to tackle the housing crisis in Northern Canada by integrating computational design tools with CLT and 3D printing technologies. We offer a new way of thinking about sustainable housing in the extreme climates. While this method is still theoretical, it also great potential for future application. And to address this limitation and for future research, could focus on several key areas. For example, we have the wall composition studies. By exploring insulation effectiveness, the structural performance, and the use of eco-friendly materials to improve sustainability, the simulation and the testing for develop advanced simulation tools to evaluate construction performance under real Arctic conditions. And for the assembling between CLT and 3D printing structure, we need to be careful by avoiding the thermal bridging and the air gaps. And finally, incorporating traditional buildings practices through community collaboration and workshops. It may help to ensure culturally appropriate solutions. Thank you for your time, and I look forward to any questions.
Thank you, Yakine. Do you have questions? So Yakine promises to continue this research, and he was admitted for a PhD starting probably in January, given that he defends well his master's before, of course. Okay, yeah. So we have our next presenter. Thank you, Yakine. No question here. Maybe the fact that you are not with us influences this, but anyways, thank you. Yeah, next time.
Yakine, can you stop sharing your screen, please?
Sure.
So Bruno Love is the next presenter, and he just defended his master's a month ago. And he will kind of continue the topic around prefabrication, this time not in extreme zones. Yakine, you have to stop sharing. Oh. Ah, ok. Super. Faut que tu switches les écrans.
Là, tu peux l'agrandir.
Ouais.
C'est ça. Et normalement, suivant.
Okay, super.
Here we go.
Okay, you have the floor.
All right. Thank you. Hello. Thank you, everyone, for being here. For me, it's a big responsibility to be in front of you and also a great honor. Well, my name is Bruno Llave. I will speak about my research topic in my master program, which is Design Configurator for Mid-Rise Modular Residential Buildings. Thank you for that. Well, under the kind supervision of Ivanka Jordanova. Okay, so a little bit of context. Although off-site construction has many benefits, its adoption is hindered for many things, but one of the most relevant for my research is the extensive lack of knowledge in logistic manufacturing and assembly from the early project stages. So as an architect, I wanted to do more for try to find or contribute to find a solution for the housing crisis, and why not take advantage of off-site construction methodologies. So I feel that we can do more to solve the housing crisis. And this is why my objective is to encourage the use of off-site construction through BIM-based automated systems, offering efficient and sustainable solutions for the housing crisis. I started my journey with a literature review using the snowball technique, which gave me a general first picture of the knowledge field. And of course, after that, I had more questions, and this is why I performed a systematic literature review following the Prisma statement. So some of the most relevant findings in this period was, one of them was the typology classification of the configurations that was provided by Cao in 2021. He stated 3 types of configurators. The first one is a planning configurators used for basically arrange volumes of the building. The second one, a design configurator that provides a 3-dimensional model that brings us also the opportunity to evaluate different key performance indicators, and the production configurator that translate the design information to the manufacturing stage. I also perform a keyword concurrency analysis that allow me to understand which type of functions does a configurator should fulfill in terms of BIM and off-site construction in the different construction fields like architectural design, structural design, product design, manufacturing, and last, workflow to develop and implement a configuration system based on the proposal of Popovic. The steps that Popovic states are in gray, mine in white. And this workflow it's very relevant for my research, so I will come back later. So the main objective of my research is to develop a configuration platform for modular residential architectural design that address the knowledge gap in logistic manufacturing and installation. For that, I use the design science research frame. I already spoke about the identified problem stage, define objective of a solution. I already spoke about that. So the next stages will be part of the next slides, which are design and development of the artifact, demonstration, evaluation, and communication. So how I started to design this artifact? Firstly, I compared the different available configurators in the market. I use the functions that I get from my systematic literature review. And I also use information about previous research of Grid Lab that identifies industry needs in terms of adoption of site construction methods. So in the first column of this comparison table, we can see the configurator type according to CAO categorization. In the third column, we can see the different criteria that I used to this comparison. And in the second one, we can see the source of this criteria. And the evaluation was a yes or no evaluation of these softwares. So at the end, I can conclude that any of these tested configurators provide automation through the entire process. So I based my artifact in these criteria and in the workflow that I explained at the beginning. So to do that, I just removed the evaluation steps because due to the multidisciplinary nature of a construction project, I won't be able to fill these steps. So I gather the steps in 3 sections: the parametric elements database, the computational design for configuration systems, and outputs and information evaluation. So the first section is about the parametric database. For that, I use a BIM database, a BIM parametric database that I made myself, and an external database that allow me to compare, to evaluate different key performance indicators about CO2 footprints or cost. So about the parametric database, it has different hierarchy levels, what we can see at the right side from the bottom to top. The architectural units are the architectural units itself that makes the catalogs that of units that we are going to use to make the building. The volumetric modules are the modules that compose these architectural units. And these 2 levels are very special because in the specialties for each module level and in the kit of parts, I applied a hard parameterized approach that allow me to automate, not fully automate, but bring some automation tools to modify the catalog and considering some constraints like the sizes of the modules or the numbers of different elements that we need to accomplish with the regulations. So once that we have our parametric catalog, we need to put it in a building, right? So for that, I propose to use a central axis. That will be the first step. From this central axis, we can get a bidimensional matrix of virtual containers. And we can create a 3-dimensional matrix just inputting the height of the building or the number of levels. So from that, we will get a matrix with 5 rows. The row 1 and 5 will be used for the balconies volumes. The row 2 and 4 for the architectural units. The row 3 for the horizontal circulation. And for the roofing, I apply a bidimensional matrix. So this method doesn't only allow us to create standardized buildings just with one type of results. We can also customize. In this case, I propose a script that just selecting the place that where we want to put the new module. We can just replace the old module easily. From a standardized template, we are also able to get manufacturing drawings. And we are also able to calculate the different CO2 footprints of different kinds of elements, allowing us to make comparisons between different material options, right? Like if we want to use a CLT column or a glue lamp column or any type of option, right? So here I have a short video about a real case studio. So everything started drawing the central line of the building. After that, I selected and just move some parameters like the number of architectural units that we want for apartments of 3 bedrooms, 2 bedrooms, studio units, the levels of the building, how do we want to arrange these units. And in the dashboards, we can see the different indicators about the cost estimation, the CO2 footprint. And after we get our desired configuration, we can just click in generate and get the 3D model and the manufacturing information. And we are also able to get some schedules that will allow us to make the comparison of the indicators. So in this video, we can see how does this prototype works. We just need to select one option of material for columns, let's say, and then select the other one and generate the comparison in the same Revit model. So some conclusions of this research work was that the configurator is able to constrain the sizes of the modules that we are going to use in the process. It shows us a warning message if we are not accomplished with these constraints. In the manufacturing aspects, the parameterized kit of parts provides manufacturing information for each element, and it also allows to automate manufacturing drawings. In the installation aspects, the predefined catalogs ensure modules are assembled according to the building system, and softwares like Navisworks, Synchro, or others can be used for the planning management. And from a sharing information aspect, different BIM models can be used in collaborative platforms like Autodesk Constructions or similars. So finally, some contributions of my works are that it lists some functions that are used for configuration platforms in the building industry. It provides a framework to develop a configuration platforms covering from the initial design to the manufacturing short drawings. And finally, it links database in BIM projects, providing sustainability and cost indicators for informed decision making. Well, some bibliography, and that's it. Thank you.
Thank you, Bruno. Questions? Do you have questions? Okay, I can see that people started getting tired. Okay, so Bruno's work raised quite a lot of interest in industry, so several companies are kind of pulling on him now. So thank you again, Bruno. And next will be a very colorful presentation. Might be even some noisy presentation, we'll see, by Saba Kakavant. You have the floor, Saba.
Hello, everyone. Thank you for coming today. I am doing master's under supervision of Ivanka, and I'm very excited to present our research project, Database Art to Enhance Users' Pro-Environmental Behavior. So when we're talking about building sustainability, there are many aspects and disciplines involved. And there has been a huge focus on technological advancement to make our buildings more automated and promote the building sustainability. However, the users or occupants' impact is very significant on building sustainability. And there has been some efforts to use the building data and present it to users to give them a better concept of how the building is functioning. Because when we're looking at the building through the eyes of the users, we don't know exactly how a building is going through the sustainable path and how we can participate and contribute in this way. As there has not been an effective, compelling way to communicate this building information and make that link and connection with the users to drive this eco-conscious choices, our main objectives are transform this building data into a form of captivating art through the process of data art and using generative AI art, and to eventually influence individuals to adopt more pro-environmental behaviors. So we're going through these outlines one by one, and we are, of course, starting with definition of the pro-environmental behavior, where my literature review started. So pro-environmental behavior defined as actions aimed at minimizing negative impacts on both the natural and built environment. We're not trying to be perfect, but we're trying to minimize our negative impacts. And the human behavior is influenced by internal and external factors. And when we're taking a look at the principles of pro-environmental behavior, there are a few that plays significant roles, starting with environmental awareness as a base, through education, social media. We get this idea of how our environmental is functioning, and we can build better connection with our actions and the environmental consequences with more awareness. But here comes psychological distance, where I found it very relative these days, is the fact that how we feel detached from the environmental consequences around us, and we're not really seeing our part, our role in the big picture. And the social influence, the more the community around you is acting more sustainable, you're also trying to just do your actions aligns with them. And the value and beliefs that make it more personal, that maybe deep connection with nature or different aspects of your life that helps you to act more sustainably. It's good to have an idea of the barriers in the way, both in individual and social context. There are a few types of barriers that we might face it, like individuality, the wrong scope of people, the community, or lack of interest in them, responsibility that comes in from a lack of trust. Maybe they don't own really property that they care about the environment around, and practicality that can be time and money, encouragement, facilities around. They all can play a role, and we try to tackle them. So what is exactly the role of art here? I found this diagram very insightful, because in an ideal world and perfect project is where we are implementing the interdisciplinary approach to tackle these problems, where scientists, artists, activists, they come together, and each of them play their part. Scientists, they are more focused on analyzing the data, the facts, the reasoning, and seeing kind of what is happening exactly. And artists, it's the heart of the work, the emotions and feelings, the making that connection with the work that we see, more maybe personal aspect. And comes the activists, where they go straight to the behavior and actions to actually implement the results. A brief look at the methodology is the path we took in this year, where we start with the building data collecting. That can be anything: waste, recycling data, carbon emission data, water usage. We will narrow it down, but the data can come from databases, sensors, equipments, and of course, analyzing the data to have a better idea of the correlation, the anomaly, and to see what part of it is playing a better role for our project. And to pass through our sustainability assessment to see how far close they are from the sustainability standards. And then to have a raw representation of the data that makes it ready for the last step, that is creating the art. So just to have a better idea of the database, we don't really need to go to details here, but the tree of the database that we're using from ETS has these different parts that you can basically mix and match the tables to create the type of data that works better for you. And then it's the insight and analysis that we need mostly from this data. For example, how frequent this data is being captured from 15 minutes to 1 second in some zone. It can be different based on the functionality of that zone. And the indicators we're picking are the most captured one in the building: the temperature, water consumption, and electrical usage. And how sustainability classification works is very simple, basically based on thresholds that are set by a university and the change of seasons that also play a big role. And for the raw representation in the form of a simple shape that just change with the size and color based on how sustainable the indicators are. Okay, so here comes the big picture of the idea that we're trying to generate, and it's a garden of sensors. And the garden sensors were basically trying to create these flowers with the data coming from each of these data points. And it depends on how sustainable that zone is. The flowers grow bigger, and the less sustainable it is, simply you cannot see that much flowers. So you can have that clear image of that zone and compare it to other zones as well. And also that can be more accurate because we are matching both the flowers that are picking from the endangered plants in Quebec and the accurate data that's coming from our data points. But why flowers? So it's been proved that flowers and plants they trigger the brain of a human and create that feeling of empathy with nature. So we can better build that link, that connection with our behavior that is reflected through this data coming from the sensors, and simply building that connection with us and the building that we're interacting with. To make that idea happen, we need a tool that can have that accuracy, but also can create art. And Touch Designer has been a very useful software for many purposes. It's a node-based visual programmer software. It works on GPU and doesn't crash with big data set. And we can simply pass our numeric data that is coming from our building through different forms of shapes, textures, surfaces, without touching the nature of the data. So when we normalize this data and we want to visualize it, we can visualize it in different forms, but the nature of data stay intact. That's very important for us. And yes, and the art generating engine does its work. So the circles that we were talking about, that we are putting them in based on some grids in that zone. And I specifically picked this one because there are we can see more sustainable data coming from one part and maybe less active in another part. And for the first step, after we visualize the simple shape of circles, we transform it to a more flexible form of these textures that we can simply better play with. It's the same area occupation, but just a different form. So we have that accurate data, but we're just changing the forms. And in the next step, we transform these textures and shapes through the sustainable diffusion engine that is embedded in the software. And we have full control of every step of the part, as it can also be easily programmed. And if you squint your eyes a little bit, you can see how similar these both representations are. And the interesting thing that you can see from the work of stable diffusion is how it connects these different data points together and creates a more compelling visualization of that part. So even though in one part maybe a few of these data points are not showing that much of a sustainable data, you can still see that they're creating the big picture of the flowers because the average sustainability of that zone is doing good. So it's easier to just convey this message to users that how the zone that you are active in is doing good or bad. And then the other zones that maybe are not doing that good, they can just transform to some vague shapes or colors, or they create some kind of backgrounds for the flowers. And there has been some ideas to improve the user experience through the sound and make the flower visualization audio reactive. But it hasn't been very successful so far, as converting the raw data to sounds is pretty challenging. And so far there has been this proposal that we can use other sounds that maybe we are more familiar with, like the sound of birds, that also really helps our mental health. And doing some oh, nice. And doing some noises from that part of the data that is not being that sustainable, so we can understand the audio and how good is working and just relate it to the visuals too. And for the evaluation part, we are planning to do some interviews and getting feedbacks from the users, how they felt about the installation. And we use the ChatGPT plugins embedded in the software again to convert that speech to accurate text and store it, and then label that data with the pre-trained conversational AI model. It's pre-labeled, so we're basically just getting an idea of how people generally felt about seeing these visuals and audios. And we can get some insights. The next step in future is just to make it more accurate, because there is still things to be done. And we can also collect instant feedback through the software, make it more interactive. We can link any kind of sensors to the software to get direct feedbacks from users in that context of installation. And also long-term monitoring can be a good future goal to see how that behaviors shape a pattern over time, and also how the building executives can also use this form of presenting data to help the sustainability the building. Yeah, thank you so much. Any questions?
Okay, thank you, Saba. Do you have questions? Yeah, okay, Ahmad.
Thank you. So it's really interesting, but just to make sure that I'm understanding well, so you're gonna hang like that dashboard or screen, like let's say as example in a building, and then the end user will see that screen and figure out their zone, and based on the picture there, they will determine whether they are doing well or not in terms of sustainability practices, right? So would it be better if the screen in each zone show only the data from that zone? So in order I see the screen, I need to figure out my zone and see if it's background black or if there is a flower. Why not have the screen showing only the data from that zone? So whether I will see something like related direct to my specific area.
Well, that's definitely a good idea, but for just implementing it easier, especially in the context of our university, so we're thinking about a bigger screen that can show maybe each labs. So we have like one station to gather that feedbacks, but in the long term, we can also do it for different zones.
Yeah, good luck. Thank you.
Yeah, thank you so much for yeah.
Also, it's good to be able to compare yourself to everybody else.
that competition.
Well, yeah, it's a very initial idea about representation. Yeah. Other questions?
Just have a reflection. So here, if we behave well, the flowers grow. Basically, whatever we do is somehow affecting negatively to the nature. So what if we are consuming too much, there is the flower that dries out, or if you're behaving in a way that is more damaging, it shows like another approach. Instead of like flowers growing, it shows that animals are dying or flowers are drying out.
Yeah, that's definitely an aspect to be considered in future. I had this idea to show the flowers dying or like getting dry, but it's hard to implement it because it makes it a little bit complex and chaos. So visually, it's hard to see. But maybe if we have different screens, we can put that idea to work. Yeah,
and stimulate good thoughts.
More focus on the good rather than the bad.
Okay, somebody else? Okay, thank you. Yeah, okay, so thank you very much, Saba. And give the floor to the mic to Salma. Okay, we're changing the topic to be a completely different stage of research and topic also. And ça va être en français en plus. OK, continue Salma.
Merci beaucoup. Bonjour à tous. Je suis Salma Hadj Kacem. Je commence ma deuxième année de doctorat sous la supervision des professeurs Ivanka Yordanova et Gabriel Jobidan. J'ai l'honneur de vous présenter aujourd'hui brièvement et d'une façon générale notre projet de recherche intitulé Système d'aide à la décision de la méthode de construction et du mode contractuel favorisant les performances de coût et de temps d'un projet de construction publique en passant par les 5 étapes. Voilà, nous commençons avec le contexte. En fait, vous savez tous que le secteur de la construction est soumis à quelques enjeux. Certains d'entre eux sont en liaison avec la construction traditionnelle. Pour les révéler, certaines études de recherche ont montré que la construction modulaire pourrait être la solution. D'autres enjeux sont liés aussi au contrat transactionnel traditionnel et les contrats relationnels collaboratifs ont été proposés aussi comme autre solution pour les surmonter. Voilà, avec cet éventail large de méthodes de construction et du mode contractuel, les donneurs d'ouvrage se trouvent dans une situation d'ambiguïté. Dans ce contexte et dans le cadre de la prévision de notre partenaire industriel à réaliser des projets de construction publique par la méthode de construction modulaire en mode collaboratif, notre projet envisagerait à répondre à ces besoins et en lui aidant à orienter les donneurs d'ouvrage vers le choix de la combinaison le plus adéquate au contexte de leur projet. Voilà, et nous commençons notre projet de recherche par une revue de la littérature qui nous amène à constater que la construction modulaire possède certains avantages, non seulement sur les performances du projet, mais aussi des avantages socio-économiques et des avantages environnementaux. Et malgré ça, certains défis et des obstacles entravent leur adoption par les donneurs d'ouvrage. Sans oublier que la réussite de cette méthode de construction nécessite certaines conditions telles que la présence d'une équipe multidisciplinaire à la phase de conception qui pourrait exiger la présence d'un cadre juridique spécifique comme les contrats relationnels. Cette revue nous amène à distinguer certains contrats tels que la conception soumission construction qui présente le type de contrat transactionnel le plus utilisé et la conception construction, sa version émergente, la conception construction progressive qui présente avec la réalisation du projet intégré les deux contrats relationnels collaboratifs les plus récents dans le domaine de la construction. Voilà des études sur la vérification de la théorie des contrats relationnels a montré que plus le contrat est intégré, plus le contrat est relationnel, plus la performance du projet est élevée et ça grâce à l'influence des normes de comportement. La revue de la littérature nous a permis aussi de détecter certaines lacunes que je la présente par une matrice dont l'axe horizontal présente les différents contrats et son axe vertical présente les différentes méthodes de construction. En fait, toute cette partie en bleu est déjà étudiée par des chercheurs, surtout les performances de la méthode traditionnelle de construction dans les différents types de contrats, soit transactionnels, soit relationnels, alors que la construction modulaire n'était étudiée que dans le contexte d'un contrat transactionnel. La quatrième partie ici présentée en rouge, c'est les études manquantes que j'ai détectées suite à cette revue. En fait, tout ce qui est l'étude de l'interdépendance et l'interdépendance entre la construction modulaire et les contrats relationnels, ainsi que l'évaluation de l'impact de ces contrats sur la performance de la construction modulaire. Répondre à ces lacunes nous a permis de répondre de suite à notre question de recherche qui est comment choisir la combinaison entre la méthode de construction et le mode contractuel la plus performante en termes de coût et de temps pour un projet de construction publique. L'objectif principal de notre projet de recherche consiste à concevoir et définir un système d'aide à la décision de la méthode de construction, le choix entre le modulaire et le traditionnel et du monde contractuel entre le transactionnel et le relationnel, constituant la combinaison la plus performante en termes de coût et de temps pour un projet de construction publique. Pour aboutir à cet objectif principal, 3 sous-objectifs doivent être réalisés, commençant par l'identification des facteurs de sélection de la construction modulaire et le mode contractuel relationnel, passant à l'évaluation de l'impact de ces facteurs identifiés sur les performances de coût et du temps des projets de construction pour arriver finalement à développer notre système d'aide à la décision. Voilà pour la méthodologie de recherche adoptée pour notre projet de recherche et la recherche en sciences du design répartie sur 5 étapes. Nous commençons par la problématisation en définissant les questions à répondre et passer ensuite à la deuxième étape, la conception par l'identification des facteurs grâce à une revue de la littérature, les classer, les classifier selon leur influence sur les performances de coût et du temps, et arriver finalement à développer le système d'aide à la décision suivant la méthode FAHP. L'évaluation de ce système d'aide à la décision va être grâce à des études de cas. On va le tester sur des cas réels, puis on analyse et compare les résultats obtenus aux combinaisons réelles avec lesquelles réaliser ces projets, ces études de cas. L'amélioration de notre système d'aide à la décision est l'étape suivante. Par l'évaluation de la satisfaction des différents experts, on va les améliorer grâce à leurs recommandations. Finalement, on arrivait à la communication par la publication des articles scientifiques et la présentation du système d'aide à la décision à notre partenaire industriel. Voilà certaines références et merci pour votre attention.
Merci Salma pour une présentation claire et rapide. Est-ce que vous avez des questions? Pas de questions? Oui, c'est un début de recherche, donc on a juste mis les cartes sur la table pour l'instant. Pas de questions? Non? Oui? Non? OK. Donc, on a notre dernière présentation pour aujourd'hui. Donc, on vous invite à prêter bonne attention une dernière 20 minutes parce que Mauricio va vous parler de son projet de recherche, aussi doctoral, qui concerne le Digital Twin, mais aussi en combinaison avec la Lean Construction. Donc, Mauricio, tu as la parole.
So thank you for coming. I'm Mauricio Ramirez. My research proposal is entitled A Framework Conceptualizing the Integration Between Digital Twin Concept and Lean Construction for Construction Project Management under the supervision of Ivanka Jordanova and Farud Hansen. This is the plan for this presentation, the background, process methodology, preliminary results, and conclusion and next steps. So the first motivation for this project is help solve the problem from the more big problem from the AC industry, that is the low productivity. As you know, the productivity is under other industries as manufacturing, for example. But we identify, or the question is how we can solve this problem. So in the literature review, we can identify two main approaches, the managerial approach and the technological approach. In the managerial approach is the development of some techniques, theories, or methodologies to increase their productivity. In the technological approach is some tools that can help in do some tasks more easy and more better. So the starting point for this research was study how a digital twin can help in solve this problem in the construction stage of a construction project. But we realized during the literature review that it's better combine the technological approach with the other approach, the managerial, for example, combining digital twin with lean construction philosophy. So in our exploratory study, we identified some important gaps in the literature. So in the construction stage, we identify the insufficient monitoring in other aspects than geometric aspect and safety, the lack of awareness regarding the value of digital twin for construction works, and difficulties in demonstrating economic benefits for using digital twins in construction. In the future trends and direction, we see the demand for integrating digital twin with management theories as lean construction is. The situation in other industries, as for example, in manufacturing, there is a consensus about that digital twin and lean construction can achieve synergies, but also the lack of practical frameworks to integrate both concepts. Concerning lean construction, we identify in the literature the difficulties in collect and process data in real time or near real time, at the lack of efficient integration with other disciplines as supply chain, scheduling information, and others. So how can practical synergies between digital twin and lean construction be created for construction project management? So our proposition is an artifact that enables the integration of both concepts, but based on the use of the C4 technologies. So why C4.0 technologies? Because C4.0 is the foundation of the digital twin concept. So digital twin concept needs these technologies to develop these capabilities to achieve the K digital twin service as, for example, monitor, analyze, communicate, and control. In the case of lean construction implementation, this is, it can be the K to collect and process data in real time, but also accurate data. So as preliminary solution, we propose align digital twin technologies with the implementation requirements of lean construction. But this is so complex. For example, there is not a unit in the digital twin definition, and a digital twin normally is so complex. For that, we propose defining different types of digital twin in some levels with progressive capabilities to match these LC requirements. Our research objective is develop and evaluate a framework for this practical integration. In the case, in this example, to monitor construction progress. The research method used here is the design DSR, design science research, but following a workflow to develop a maturity model, as it is shown in this picture. It starts with the problem identification, and then, for example, study the different existing maturity models to inspire on these maturity models, build a new integration model. The specific objective in this is propose a framework that implement a lean construction-based digital twin for construction progress monitoring, but it is gradually and efficient. Gradually, because it is defined in different levels of capabilities, but it is also efficient because it tries to balance the digital twin abilities with lean construction requirements. As preliminary results, we have this matrix to conceptualize this integration. How this matrix was built? In the horizontal axis, we have the different digital twin capabilities. After a study, the different characteristics of some maturity models identified in the literature review. In the vertical axis, we analyze the concepts, for example, of the degree of digitization for lean construction implementation and the degree of automation in the collection of data. This is an example. So for define this automatic digital twin, we inspired in these models to redefine this new proposition. Similar in the other side, we analyze the different concepts to redefine a new lean digitization levels from the perspective of the needs, and here from the perspective of the capacities of a digital twin. So that is it conceptualized. It was explained in this matrix is the integration between both concepts, but we define for this matrix 6 zones depending on the level of integration. For example, in the zones number 0, 1, and 2 is the case when lean construction of digital twin is implemented in siloed cases, and the other zones 3, 4, and 5 represent the integrated implementation of both concepts that can create synergies. That means that there is a mutual benefit of integrate both concepts. For example, in the zone 0 is the traditional implementation of lean construction, but without the use of C4 technologies. In the zone number 1 is also the implementation of lean construction, but without following the concept of the digital twin. Digital twin is the virtual replica of an asset or a system. In the zone number 2 is the implementation that we can say the traditional implementation is a new concept, but normal implementation of digital twin, for example, to capture geometric information in the case of construction progress monitoring. But in the other 3, 4, and 5 zones, we conceptualize the integration in the zone number 3 and the zone number 4. There is an integration, but we conceptualize that is a not efficient way to integrate. Because, for example, in the zone number 3, lean construction required for smart devices to collect this information, but the digital twin is not able to match these necessities. And similar in the other side, so it's not so efficient. The efficient zone is the zone number 5, when we have the integrated implementation, but there is a balance between the digital twin capacities and the lean construction necessities. For example, if we apply this concept for the case of the construction progress monitoring, we define inside this zone number 5 4 kind of synergy, from the basic integration to the full synergy. This synergy is defined in terms of the capacities of the digital twin to answer the requirements of a lean construction. For example, this table propose what are the capacities of this digital twin, what is the service for the lean construction implementation. In this case, this is structured in the 3 main kind of technologies that, according with the literature review, this is the architecture from for infrastructure digital twin. So there is data collection technologies, data processing technologies, the information modeling. So this proposition is structured in this way, and it is defining for each level of synergy. As next step in this research is build this table. This table represents the capabilities in terms of important characteristics of a digital twin for each type of synergy. So this is a process. To build that, we have to analyze, for example, these different digital twin classification or maturity classification. As conclusion for the moment is that this study theorizes about the characteristics and capabilities that a digital twin must have to support not only traditional construction progress monitoring that is mainly focused in geometry information according to the literature, but also the implementation of lead management in construction. And this conceptual model can increase the value and awareness of both approaches. So to fill the gap, identify in the literature review, and it suggests 4 levels of synergy that can provide better economic benefits. The evaluation is the next step also, that is finished. So we propose the assessment of this framework for industry experts using, for example, focus group technique, and finally publish this proposition. The expected contribution, there is a expected contribution for the academia, for example, promotes the theoretical foundation for the practical implementation of both concepts, combining these 2 approaches that have similar goals, but normally they work separately, and contribute to the body of knowledge on both concepts. For the industry, guide the joint implementation of the digital twin as technological support for lean construction implementation, but also lean construction acting as practical base to guide the monitoring process during construction works. Increase the control capacities by promoting this artifact, and increase awareness and value of lean and digital twin. So that is all. Thank you for
Merci,
having me.
Mauricio. Est-ce que vous avez des questions? Do you have questions? Ah.
Merci, Mauricio. Je vois le framework évoluer. C'est le fun de le voir évoluer dans ta pensée et tout. Quand est-ce que tu vas l'implanter en site? Quand est-ce que tu vas pouvoir le tester puis nous revenir avec l'implantation? C'est quoi le plan pour l'implantation?
Oui, ce que j'imagine, le framework, c'est plus standard. Je montrais ici. The first step is publish this matrix with the table, but the second stage is define in more detailed way the integration between the lean construction data requirement with digital twin technologies. So this is not yet, but can be artifact that can be used in practical application. So I expect rapidly that is.
Add a bit. We have 3 rounds of evaluation and validation. First will be with experts, so the theoretical framework. Then we're intending to gather a lot of already available digital twins. Even in our research group, there is quite a lot of cases already available, described, and to pass them through this matrix. And of course, we'll have to ask people, so was it enough or was it too much? So that we can pinpoint the place of these cases in this matrix. Is it really a waste, or was it on the good diagonal? And the third round, if it will not be a round, but it will be develop a digital twin according to this matrix and try to implement it. Of course, I don't know if we're going to be able to reach this level, but there are some ideas around the, by the way, the SPAC. So we'll see, maybe we'll be able to develop a real case and to use it constructively. Other questions? Okay, a big round of applause then for a job well done. And I have just a few more slides. Est-ce que ça fonctionne ici? No. Donc, we're having our fourth or fifth. Wow, it's a big anniversary. So we're at industry 5.0 now. It's not 4.0 already. We're like, okay, we're including the person, the humane. Because this is supposed to be industry 5.0 should be around the human and technology, but mainly human-centric approach. So what will be the follow-up? What are we doing next? A lot of things. First of all, we have to continue what is there and what has been begun. And as you know, we have a new, more flexible and open collaboration model with industry, with industrial partners, which is through a memorandum of understanding. And 5 of you, our partners, have already signed it, and we're very thankful for that. So just maybe a quick reminder of what are the main points of this memorandum of understanding. It's very simple, very easy to kind of to adopt. It has 3 main points, I would say, from my absolutely not legal perspective. So don't cite me to any people from the legal department, but it's roughly to participate in the activities organized by GRID, so like this kind of activities, to have a financial contribution for projects which are of interest for your company, and this at least once every 2 years. So this is actually the most constraining part. And then to give your data to be available for research by students in the group here. So these are the 3 major points. Now we have some other projects which are kind of beginning or will start soon. Vous savez, now I'll switch to French. So we have the Alliance grant from NSERC, which is around the feuille de route gouvernementale pour le BIM. And there we're targeting the performance indicators. And it's a very big research proposal put together by Eric. Which includes many other university professors and public owners. Then we have our playground here, the ETS, with the new project of the new pavilion DAO, which will be the first big IPD project in Quebec. I say the first big one because I know there are some smaller ones. So we are trying to test many different concepts there, various innovations. We are involving the users, the conception intégrée, various innovations, and it's ongoing actually the process of accompanying our university to go through to implement these innovations. Then we have SQI with some projects around modular offsite construction and collaborative project contracts. NRC, the National Research Council, who have a big program now for digitalizing and industrializing construction. So we are very much involved in various aspects of this program. The Quebec Funds of Research and Innovation there are some projects around prefabrication and 3D printing also. And finally, the réseau de recherche en économie circulaire du Québec, oui. So that's where we have a couple of projects around circularity and reuse of elements, even if we heard that some people are skeptic about the reuse, but we'll see what can be reused, what cannot. And actually, there is a project also on adaptability. So can we design buildings which are adaptable and not we have to disassemble them and reuse elements? So these are maybe just part of the projects. We're also teaching, by the way, I don't know if you know here, but we have around 10 courses on master's level that are given by all my colleagues here and some other colleagues. And some of you actually are adjunct professors, chargés de cours also in these courses. So we just put together a new course on BIM and GIS for civil infrastructures. And I know there is a project for a course on IPD, which probably will be there next year. And now actually, I want to thank everybody who participated. Drouin Consultants is, yeah, Daniel is there. Thank you very much for sponsoring the cocktail. We're very happy to have you around. Yeah, thanks to all the bénévoles. Oui, merci à tous les bénévoles, volunteers, yeah. And a message from them. There are lunch boxes which were prepared from all the food which was remaining after our very generous lunch. So students who leave from here, you can take a lunch box for home. And also les cocardes, s'il vous plaît, laissez-les à la sortie. Parce qu'on va les recycler, en fait, on va les réutiliser. C'est les mêmes cocardes qu'on utilise pour plusieurs conférences. Alors, surtout ça, merci à tout le monde. On vous invite ici pour une photo de l'événement, s'il vous plaît.
Et bien évidemment, merci à tout le monde en ligne. Bonne fin de journée. Le monde en ligne, c'est juste nous autres.